Welcome back to Sleep Nova. Sit back, relax, and don't forget to comment where you're watching from down below. It's amazing seeing people all around the world supporting my small channel. Now, enjoy the show. Imagine yourself lying on a soft meadow on a clear night, far from any city lights. The air is cool against your skin, carrying the faint scent of grass. Above you, the sky is a black, velvet dome sprinkled with countless stars. The Milky Way arches overhead, a pale river of starlight. In this quiet moment, you feel deeply connected to the cosmos. The same space that stretches between those stars also surrounds you. A gentle breeze brushes your cheek. It moves through the night and through the space around you, here on Earth. As you gaze upward in comfortable silence, more and more pinpoints of light emerge, a glittering mosaic against eternity. You realize that when you look at these stars, you are literally looking back in time. Their light has traveled for hundreds or thousands of years to reach your eyes tonight. Some of those stars may have already lived out their lives and vanished, yet their glow still journeys onward through the dark to greet you here and now. You feel the solid earth beneath you and know that it too is suspended in that great darkness, a small, warm world afloat in an ocean of space. Yet you are not afraid. The darkness above feels inviting, almost comforting, like a vast shelter. The endless sky, rather than making you feel insignificant, fills you with peace and wonder. In the silence, you sense with gentle certainty that you are a part of this grand universe. The starlight that falls on your skin, the space that cradles your body, the photons entering your eyes, all of it binds you to the cosmos. You close your eyes for a moment. Behind your eyelids, the after-image of the stars dances in little sparkles. You take a slow breath in, and as you exhale, you let any tension flow out of you and into the vastness around. There is room for all of it to dissolve. There is room for everything in space. The universe is so wide and forgiving that your own cares begin to feel lighter, quieter, soothed by the infinite calm. Now, in that spirit of tranquility, let us embark on a journey into space itself. The space around us, the space within us, the space that is the foundation of all things. We begin where we are, in stillness, in the darkness, in the quiet. The night is profound and motionless. Above, the stars shine as tiny islands of light in a vast sea of black. Space stretches endlessly between and beyond them. This scene feels serene and timeless. Nothing stirs. No breeze now, no sound at all, only a gentle hush, the natural silence of a cosmos at rest. It is as though time itself has paused. You can almost feel the depth of this silence, a soft, velvety silence that blankets everything. The emptiness around you seems to embrace you with a subtle, invisible presence. For ages, we humans looked at the night sky and found it peaceful, but also mysterious. What is this blackness between the stars? We used to think it was nothing, an empty void, an infinite vacancy. People spoke of the void and the vacuum as if it were a true nothingness. We even doubted whether a true vacuum could exist at all. Ancient philosophers imagined that space must be filled with something. Aristotle believed nature abhorred a vacuum. Later, scientists in the 19th century hypothesized an invisible ether filling space to carry light across the emptiness. But experiments showed no such ether was needed. Light moves through empty space itself. This was a remarkable discovery. The void can carry light, as if emptiness has its own solidity. It hinted even then that space is not simply an inert backdrop. For a long time, though, the common view of space remained that it was a passive emptiness, a gargantuan container in which the objects of the universe, planets, stars, galaxies, are scattered. We pictured space as a stage and the stars as actors upon it, with no real influence from the stage itself. If you removed all the actors, the stage would just sit there, blank and silent. We imagined that if you took all matter away, you'd be left with pure nothing, an absolute void, infinite and eternal. Over time, however, our understanding evolved dramatically. We learned that space is far from nothing. That black backdrop, that stillness and silence, is deceptive. Space has properties, a structure, a dynamic of its own. In the past century, every new discovery has reinforced this truth. Space can bend. Space can carry light and soundless vibrations. Space can stretch. It can even boil at the tiniest scales, flickering with unseen energy. What we once thought of as an empty stage is more like a participant in the cosmic play. Tonight, as you float in this quiet moment, the darkness around you is not dead or inert. It is the very fabric that connects and supports all things. Let's explore this step by step, gently and thoroughly, starting with one of the most profound revelations, that space and gravity are intimately linked. Beneath you, the Earth's mass is pulling you down, or rather, it's warping the space under your body so that down is the direction you naturally fall. Above you, the moon is held in its orbit by the shape of space around Earth. This understanding comes from Einstein's great insight in the early 20th century. Gravity is not a mysterious force acting across empty distance, but a feature of space and time itself. Mass and energy tell space how to curve, and the curvature of space tells objects how to move. In essence, matter sculpts space, creating valleys and hills in the fabric of space-time, and objects simply roll along those curves. What you feel as gravity, the weight on your back as you lie in the grass, or the pressure of your body against your bed, is actually space itself pushing you downward, guiding you along the curved lines it has formed around the Earth. To visualize this, imagine space as a vast elastic sheet spread out under the stars. If you place a heavy object on that sheet, say a bowling ball to represent a star or planet, the sheet will dimple, sagging inward around the weight. Now, if you roll a marble nearby, representing a smaller object like a planet, the marble will no longer travel in a straight line. It will spiral around the bowling ball, caught in the curve. In reality, Earth orbits the Sun because the Sun's mass curves the space around it, creating a sort of well that Earth is rolling around. Earth thinks it's moving in a straight line, and indeed it is, locally, but space itself is curved, so straight for Earth is actually a loop around the Sun. There is no gravitational force pulling Earth in a literal sense. Earth is simply following the path allowed by the curved space, like a ball rolling around a curved bowl. All planets, all moons, all orbiting bodies are doing the same. They are not tethered by invisible strings. They are skating along the contoured roads of space. Right now, as you lie still, you are held to the ground by this phenomenon. The mass of the Earth has curved space under you such that down points toward Earth's center. Your body presses into the ground because space is telling you to move that way. The ground pushes back and holds you up. Space does this quietly and continuously. You feel the effect as weight, but really, it is space-time gently urging you along a curved path that the solid Earth prevents you from taking. If Earth were not here, that curvature would extend unopposed. You would fall freely along a path through space toward where Earth's center was. All of this happens with no sound and no drama. Space does its work quietly. In essence, what we experience as gravity is the shape of space around us. Matter, like the Earth beneath you, tells space-time how to curve, and that curved space-time tells matter how to move. Gravity is not something that reaches out through space. Gravity is space. The stillness around you, in fact, is full of these invisible curves and subtle depressions wherever there is mass nearby. If you could see the geometry of space, You'd see gentle indentations around every tree, for even small objects curve space a tiny bit. Deeper wells around the mountains, and a huge well under your body, reaching to Earth's core. But space does its job so smoothly that you don't notice anything odd. You just stay attached to Earth as naturally as a leaf rests on the ground. This idea also means that when a massive object moves, it can create ripples in the fabric of space. Much like a stone dropped in a pond sends out waves on the water. Imagine two massive stars circling each other rapidly, or better yet, two black holes, extremely dense objects, spiraling together. They disturb the space-time around them so much that waves of curvature spread outwards. These are called gravitational waves, literal ripples of space traveling at the speed of light, washing through the cosmos. For a long time, we weren't sure these ripples really existed, but in recent years, scientists built instruments so sensitive that they could feel space-time tremble. When two distant black holes collided and merged, in a galaxy billions of light years away, our detectors on Earth quivered ever so slightly. Space itself stretched and squashed by a tiny amount, far smaller than an atom, as the gravitational wave passed through. We heard the universe whisper through space-time. It was as if the stillness briefly sang a faint melody. Think about that. We built a device that can sense the movement of space from events that happened billions of years ago in far-off corners of the universe. When we detected those waves, it confirmed that space-time is not just an abstract idea. It's a real, physical fabric that can carry vibrations. Space can ring like a cosmic bell, even though we cannot hear it with our ears. In September 2015, when those two black holes merged, the fabric of space around Earth oscillated subtly, and our instruments recorded the telltale chirp. It was a triumph of human curiosity and a profound validation of the idea that emptiness has structure. The silence of space isn't absolute. If you have the right ears, space can indeed be heard. What an elegant picture, space as an ever-present elastic medium, carrying both the weight of stars and the whispers of their collisions. In summary, matter tells space-time how to curve, and space-time tells matter how to move. Gravity is not a pull through some void. It is the gentle guidance of objects along the contours of space-time. All of this, the Earth holding you, the Moon orbiting Earth, Earth orbiting the Sun orbiting our galaxy's center, is happening because space itself is shaped by mass and energy. Our everyday experience of weight is actually our intimate connection to the shape of space. So, from the stillness of space arises what seems to be a force, but space has more surprises. We've talked about space's shape. Let's now consider its unity with time. When Einstein described gravity as the curvature of space-time, he was saying something equally profound about time. That time is woven into the very fabric of space. Out in this quiet night, space and time seem separate. You can point in directions, you feel time passing. But experiments and theories show that they are inextricably linked. If you move fast or sit in a strong gravitational field, your experience of time changes relative to someone elsewhere. Space and time together form a four-dimensional weave, and gravity is the bending of that weave. Consider that the passage of time on the surface of Earth is slightly slower than time far out in space, because Earth's mass not only curves space, but also warps time. A clock on a mountain, where gravity is a tad weaker, ticks a little faster than a clock at sea level. Likewise, a clock on a fast-moving spaceship will tick slower than one on Earth. This isn't science fiction. We've measured it with precise atomic clocks. Even the GPS satellites in orbit must correct for time running faster up there. Weaker gravity, so faster time, compared to ground. Otherwise, their positioning would drift. What we find is that space and time adjust together. If space is squeezed or stretched, time is also altered. They are two aspects of a single entity, spacetime. Think of spacetime as a fabric with both spatial threads and temporal threads interwoven. You cannot disturb one without disturbing the other. When the sun's mass curves spacetime, not only does space get warped, but time runs a bit slower near the sun compared to far away. An astronaut near a massive object ages a bit less quickly than one floating in weaker gravity. This is called gravitational time dilation. Similarly, if you travel at a speed close to light, time for you will slow relative to those you left behind. There is a famous thought experiment. Imagine twins, and one goes on a near light-speed journey to a distant star while the other stays on Earth. If the traveling twin returns after what she feels was perhaps a few years, she might find decades or more have passed on Earth. Her clock and body experience time more slowly due to her rapid motion through space-time. This isn't just a story, it's a real effect, verified by many experiments with particles and precise clocks. All of this tells us that space and time are not the separate, absolute backgrounds we once assumed. There is no universal time ticking the same for everyone, regardless of their state of motion or gravity. Instead, every observer has their own passage of time, depending on how they move through space and how space is curved where they are. Two people reunited after following different paths through space-time will have experienced different durations. What an astonishing reality. Time itself is elastic, flexible, personal. So here, under the stars, when you consider a moment of time and a stretch of space, realize they are part of one four-dimensional continuum. Here and now are bound together. You cannot point to a location in space without also specifying the moment in time. Everything that happens in space-time. The unity of space and time frames all experience. Right now, your heartbeat and the position of the moon both have coordinates in space-time, and gravity is the geometry of that space-time linking the two. Space and time are fused like two threads of a single fabric. Move fast through space, and you skew your passage through time. Stand in strong gravity, and time for you will run a bit slower than for someone far away. This interplay might sound complex, but think of it this way. Space alone isn't the full stage, and time alone isn't either. Rather, events unfold in space-time. If you try to separate them, you lose part of the picture. Even this peaceful moment has a space-time coordinate. You, here and now, under the night sky. As you lie there, time flows a tad differently than it would if you were orbiting the Earth or sitting on the moon, because the gravity and motion differ. The differences are small but real. Space-time enfolds you, ensuring that your now and here are connected into the grand tapestry of cause and effect that makes up reality. The important takeaway is, space and time are one fabric, and gravity is the bending of that fabric. The stillness you feel includes both space and time quietly doing their work. There is a timeless quality to this night because space and time together create that sensation. In this eternal present, you are embraced by space-time, which gently carries you along the stream of time while holding you in the structure of space. We have journeyed outward to see that what we thought was emptiness actually shapes the cosmos, and journeyed inward to see time intertwined with space. But the rabbit hole goes deeper. We must now explore the nature of space at the smallest scales, far smaller than a grain of sand, smaller than an atom, where an entirely new picture emerges. One might expect that if you zoom into space closely enough, you would eventually find absolute stillness and uniformity, perhaps even true nothingness. But our current understanding, through the lens of quantum physics, says otherwise. On extremely tiny scales, space is anything but smooth and still. It is frothing and fluctuating, buzzing with ephemeral activity. Physicist John Wheeler poetically called this the quantum foam. To grasp this, imagine shrinking yourself down beyond the microscopic, beyond the level of atoms, to a realm billions of times smaller. If you could stand there, if the word stand even makes sense at that scale, the tranquil emptiness you perceive at our scale would vanish. Instead, you'd witness space seething with spontaneous eruptions of energy. Particles would blink in and out of existence like fleeting sparks. Distances and directions would blur as uncertainty reigns. In quantum physics, even what we call a perfect vacuum, completely devoid of matter and cooled down to remove all heat, is not truly empty. There is a fundamental jitter that cannot be removed. This is because the laws of quantum mechanics tell us that certain pairs of physical properties, like energy and time, or position and momentum, cannot both be known with infinite precision. There is a built-in uncertainty, and because of it, a vacuum cannot have exactly zero energy for all time. If it did, we'd know both its energy, zero, and that it stays that way, no fluctuation, forbidden by quantum rules. Instead, the vacuum seethes with what we call zero-point energy, a baseline, irreducible energy. What does this mean in practice? It means that empty space is constantly witnessing tiny particles flickering into being from nothing, then vanishing almost immediately. These are often called virtual particles. For example, a particle of light, a photon, might momentarily pop into existence, along with a counterpart, perhaps an electron-positron pair, borrowing energy from the vacuum for a brief instant. They appear, exist ever so briefly, and then annihilate each other, paying back the energy. All of this happens on timescales and distances so small we normally have no way to detect it directly. But it's happening everywhere, all the time. The space around you, between you and the next breath of air, between the electrons and nuclei in your body, between the Earth and Moon, is awash in these quantum fluctuations. On the scale of the unimaginably small, much smaller than an atom's nucleus, spacetime would not look like a smooth sheet. It would look like a turbulent ocean surface in a storm, full of random waves, bubbles, and wrinkles, hence quantum foam. One moment, a bit of space might have slightly higher energy, sprouting a virtual particle-antiparticle pair. An instant later they collide and disappear, leaving a slight vibration of energy that then might spawn another pair elsewhere. Space at that level is a riot of spontaneous activity, an invisible, high-speed flickering that averages out to a seemingly smooth, stable whole at larger scales. We've even observed tangible effects of this quantum vacuum. If you place two metal plates extremely close together in a vacuum, just a few nanometers apart, they will experience a tiny force pushing them toward each other. This is the Casimir effect, and it happens because the quantum foam between the plates is slightly different from the foam outside. Certain virtual particle wavelengths can't exist in the narrow gap, so there is a tiny imbalance, fewer electromagnetic modes between the plates than outside. The result is a subtle pressure that nudges the plates together. In essence, the empty space between the plates has less quantum activity than the space outside, causing them to be pushed inward by the more energetic fluctuations outside. It's a small force. You'd need sensitive instruments to measure it, but it's real and has been observed. It's as if the vacuum between the plates is not nothing. It exerts a gentle push. This is a direct demonstration that empty space is never truly empty. The vacuum is alive with energy and possibility. In particle physics experiments, we also see clues of the quantum vacuum. For instance, empty space can briefly lend energy for the creation of particle pairs that affect processes like nuclear decay. The very fact that protons and neutrons inside atomic nuclei can change forms via quantum fluctuations involving ghostly particles is tied to vacuum activity. Even the stability of atoms and the patterns of atomic spectra bear the imprint of zero-point energy. So, as incredible as it sounds, the takeaway is that emptiness is not truly empty. It's an active medium. The stillness we perceive is actually a frenetic dance at microscopic scales. The vacuum is constantly borrowing energy here, giving it back there, in accordance with quantum uncertainty, Put poetically, even when nature whispers hush, there remains an undercurrent of subtle noise, a quiet fizz of existence and annihilation on the tiniest scales. The concept of nothingness has been forever changed by this discovery. Empty space is a cauldron of potential, a field of fields, a stage for ceaseless miniature drama. If you were to shrink down into that realm, as a moment's imagination, since physically we cannot, you might see space flicker with tiny flashes, the foam that Wheeler described. It wouldn't be placid or uniform, it would be dynamic and random. The notion of a sharply defined point in space might lose meaning, blurred by these fluctuations. We sometimes say spacetime becomes quantum foam at the Planck length, about 1035 meters, far smaller than any particle. At that scale, the smooth geometry of spacetime breaks down into something probabilistic and fluctuating. Let's take a different kind of imaginative journey to appreciate this. Inward, into the fabric of matter and space inside you. Envision shrinking yourself, as we did under the stars, but now not in distance outwards, rather in size. You diminish down past the scale of dust mites, past cells and their nuclei, past even viruses and DNA molecules. Now you are smaller than an atom. Ahead of you floats a single atom of carbon from your body. It appears enormous from your current perspective. You approach it like a tiny spaceship nearing a planet. The atom consists of a blurry sphere, that is the cloud of electrons orbiting the nucleus. As you draw closer, this cloud is mostly transparent. You realize the electrons are tiny points moving so fast, they form a diffuse shell. You dive through this wispy shell of electron probability and find yourself in the interior of the atom. Suddenly, you are in what seems like a vast cavern. It feels eerily similar to drifting in space between stars. It is dark and almost empty. You might even see a faint glow of energy fluctuations around. The quantum foam flickers here too. For a moment, it's as if you're floating in a miniature version of outer space, a huge volume with almost nothing in it. Ahead, after some distance, you see a tiny but brilliant object, the atomic nucleus. You move toward it. What before was the immense atom is now mostly behind you. All that's left ahead is that nucleus, a cluster of protons and neutrons tightly clumped. It's small, incredibly small. If the whole atom were a cathedral, the nucleus would be like a single grain of sand at its center, and yet, that grain of sand holds almost all the mass. You come right up to the nucleus. It's made of particles bound together, busy with internal motions, but you cannot linger. At this scale, forces are intense. You decide to zoom back out. When you return to human scale, you carry with you a profound appreciation. Inside every atom in your body, between the electrons and the nucleus, there are enormous stretches of empty space. In fact, nearly all of the volume of each atom is empty. The solidity of your body, of the ground, of this meadow, it's an illusion created by the electromagnetic forces of electrons repelling each other at those tiny distances. No two atoms ever truly touch in a physical sense. Their electron clouds push against each other first. Matter is a scaffold built on emptiness. It is astonishing. All the solid things we see around us are about 99% empty space. If one could magically remove all the empty space within the atoms of your body, compressing the electrons into the nuclei, you would shrink to a microscopic speck, smaller than a pinhead, yet you'd weigh the same as you do now. By some estimates, if we removed all the empty space from all the atoms of all humans on Earth, the entire human race could fit into a volume the size of a sugar cube. It sounds impossible, but it's because atoms are so vast compared to their tiny nuclei. Nature itself offers a demonstration. In neutron stars, the remnants of large stars, gravity crushes atoms so hard that electrons and protons merge, eliminating that atomic emptiness. A single teaspoon of neutron star material can weigh billions of tons. That's how much stuff was hiding in the empty space of atoms. When that space is removed, matter's true density shows. Fortunately, here on Earth, our matter stays spacious, our atoms intact with their generous voids inside. Take a moment to let that sink in. Solidity is an illusion. When we say an object, a rock, a chair, your own body, is solid, we're talking about the collective sense of touch that arises from trillions of atoms whose electrons resist being pushed into the empty space of one another. It is like a lattice of charged particles, and their mutual repulsion gives structure and firmness. But the structure is mostly empty space. We and the world we live in are made of a whole lot of nothing. It's a humbling realization. You are a being composed almost entirely of voids, shaped by forces and energy into the form you call you. In a very literal way, you are a small universe of particles orbiting each other in vast fields of emptiness. Now we have explored the microscopic character of space, the quantum foam and the atomic void. We've seen that even when matter is present, it's built on a framework of emptiness, and even when nothing is present, space is still far from idle or empty. The calm void of night harbors deep activity at tiny scales and comprises the majority of the volume of any solid thing. Space pervades every corner of existence. It is above us in the cosmos and within us in each atom. Let's step back out to the cosmic scale again. We've marveled at gravity and quantum foam and the space within atoms. But what about the shape of the universe as a whole? Does this infinite darkness go on forever? Does it curve back on itself like the surface of a planet? These questions have intrigued humanity for as long as we've looked up and wondered. Is space infinite, or is there some kind of boundary or loop? With modern science, we have attempted to measure the geometry of the universe. The answer isn't fully in, but so far it appears that on the larger scales we can observe, space is extremely flat and likely unbounded. By flat, we mean it follows the rules of Euclidean geometry, the sums of angles in triangles, etc., as far as we can see. If space had a noticeable curvature, we would detect distortions in the patterns of galaxies or the light from the early universe. The results? All measurements indicate that space is extraordinarily flat on the biggest scales. If there is curvature, it is so gentle that our observable universe, a sphere of about 93 billion light-years in diameter, doesn't reveal it. To use an analogy, Earth appears flat to someone walking a few miles because it's so large that the curvature isn't obvious at that scale. Similarly, the universe might be curved in some way, but on the scale we can survey, it looks effectively flat. What does flatness imply for the extent of space? It suggests that space could be infinite, extending forever in all directions, or it could be finite, but without boundary, like how the 2D surface of a sphere is finite area, yet has no edge, except extended to three-dimensional space. If space has positive curvature, like a 3D sphere, it would be finite in volume, and if you traveled far enough in one direction, you might eventually end up where you started, just as an ant crawling on a basketball eventually loops around. If space has negative curvature, like a saddle shape, it would be infinite and spread out with a different geometry. A flat universe, the simplest case, can be infinite and just go on and on. Current data lean toward flatness and therefore possibly infinitude, or a curvature radius so immense that for all intents and purposes it is infinite to us. From what we can tell, there is no edge to space, no wall where space ends. If it is finite and curved back on itself, going in a straight line could, in theory, bring you back to your starting point after an almost inconceivably long journey. We have looked for evidence of light wrapping around the universe, like seeing the same galaxies repeated from opposite directions, which could happen if space were closed and not too large. But we haven't found any such patterns. If the universe is finite and closed, it's far larger than the volume we can see. If it's infinite and open, it just has no end. In either case, there's no boundary that says, beyond here, there is nothing. Space, as far as we know, either goes on forever or loops back on itself. The observable part, what we can see, is certainly finite, but that's only due to the limited age of the universe and the finite speed of light. Beyond that observable horizon, we expect there is more universe, probably much more. We can summarize our findings here. The large-scale universe appears flat and unbounded. Precision measurements of the cosmic microwave background, the afterglow of the Big Bang, by satellites and telescopes have narrowed any possible curvature to be extremely slight. So, space is remarkably flat as best we can tell. It might truly be infinite. It might wrap around on a scale so huge we haven't detected it. Either way, for our observable domain, Euclid's geometry holds to a high degree. Parallel light beams do not meet, and the angles of a huge triangle drawn by, say, beams of light spanning billions of light years seem to add up to 180 degrees. This is a clue that the cosmos, on the whole, is not shaped like a sharp sphere or saddle within our view. If it is spherical, the sphere is enormous beyond imagination. If it is saddle-like, the curvature is so subtle that we haven't discerned it yet. In our contemplative journey, lying here under the night sky, it's awe-inspiring to realize we've been able to figure this out at all. By observing distant galaxies and the patterns in the microwave background, humanity has effectively used the universe itself as a giant ruler and protractor. We map the distribution of galaxies and notice that on large scales, they form a sort of cosmic web, filaments of clusters and superclusters surrounding huge, nearly empty voids. Those voids, expanses tens of millions of light-years across with hardly any galaxies, highlight again how dominant space is over matter. Matter forms a delicate lace, and space is the vast expanse between its threads. The cosmic web shows that even on the grandest scale of clusters of galaxies, emptiness stretches out between them, making up the bulk of existence. Indeed, when astronomers survey the cosmos, they see that galaxies are not evenly spread. They line up in filaments and walls, with enormous voids between. Those voids are truly empty regions, aside from perhaps the stray hydrogen atom here or there. Some voids span hundreds of millions of light-years with essentially no galaxies inside. Think about that. Such a volume is mind-bogglingly large, and yet nearly completely devoid of stars, planets, or light. Just tenuous gas and darkness. Those cosmic voids are, in a sense, pure space on the largest scale, a testament to how predominant emptiness is. The luminous matter, galaxies, clusters, outlines like scaffolding on the tapestry of space, but the vast gulfs between that scaffolding are space itself, pristine and quiet. Now, our understanding of space wouldn't be complete without touching on one of the greatest mysteries of the cosmos today, the fact that the universe's expansion is speeding up. We mentioned earlier that the universe is expanding like a rising loaf of bread, carrying raisins, galaxies, apart. You might expect, intuitively, that this expansion would slow down over time. After all, gravity is pulling galaxies toward each other. Indeed, for a long while after the Big Bang, the expansion did slow as gravity reined it in. But to astronomers' astonishment, in the last few billion years, the expansion has begun to accelerate. Galaxies are flying apart faster and faster. There is something in space, some form of energy tied to the vacuum itself, that is pushing the universe outward. We call this strange phenomenon dark energy. The name is just a placeholder, really, a label for our ignorance. It was discovered in the late 1990s when two independent teams observed distant exploding stars, supernovae, and found them dimmer, and thus farther, than expected. It was as if, over the billions of years their light traveled, the space between us and those supernovae had stretched more than it would have in a decelerating universe. At first, this result was met with surprise and a bit of skepticism. Could the expansion be accelerating? That was contrary to everything we thought. Even Einstein, long before, had considered a static, or at most slowing universe. But one by one, other evidence accumulated. Detailed maps of the cosmic microwave background and surveys of galaxy clustering both pointed to the same conclusion. Some kind of repulsive effect is at work on cosmic scales. By the early 2000s, the verdict was clear. The expansion of the universe is speeding up. So what is dark energy? In short, we don't know. It appears to behave like an intrinsic property of space. Like each cubic meter of vacuum has a certain tiny amount of energy that doesn't dilute even as the universe expands. If that's true, then as space expands, you get more vacuum, and thus more of this energy, causing expansion to push even harder, a runaway effect, though fortunately a very gradual runaway. Roughly 2/3 of the universe's total energy content today seems to be this dark energy. Only about 1/3 is in matter, mostly dark matter, plus a few percent normal matter like atoms. That means most of what's out there is this mysterious energy of empty space. It's dark because we can't see it or touch it. It doesn't emit light. And it's energy in the sense that it does work on the universe. It's causing space to swell. We sometimes describe dark energy as a negative pressure or an anti-gravity effect of the vacuum. It's as if emptiness itself has a springiness, a tendency to expand. Every bit of empty space gently pushes outward on itself. The effect is extremely weak on small scales. It's completely overwhelmed by local gravity or even the forces binding galaxies. But on the vast scale where gravity's pull has been growing weaker as galaxies get farther apart, eventually this subtle pressure took over and started accelerating the expansion again. The concept of dark energy reminds us how much we still don't know. It humbles us. We see its effects, yet the cause remains elusive. It could be something fundamental about space that we have yet to understand, perhaps related to that quantum foam energy we talked about. Those straightforward calculations of vacuum energy don't match the observed dark energy. That's a huge puzzle in physics. It could be a new field or fluid pervading the cosmos, or an adjustment needed in our theory of gravity at large scales. We gave it a name, but naming is not understanding. Dark energy is truly a question mark at the heart of cosmology. In essence, what we know is this: empty space isn't just inert nothing. It has this property that is making the universe fly apart faster and faster. The same emptiness between galaxies carries an unknown energy that currently drives the fate of the entire universe. Far from being an irrelevant void, space, through dark energy, will determine how the cosmos evolves trillions of years into the future. To put it succinctly, something latent in empty space, call it dark energy, is accelerating the expansion. The void has a sort of built-in push. This discovery is as dramatic as when we first learned space can bend. It tells us that space has a mind of its own, so to speak, a propensity not only to warp when mass is present, but to grow even where mass is absent. It's as though emptiness has a gentle heartbeat, steadily pumping the universe larger. So now we have seen space from two extreme perspectives: the microscopic, roiling with quantum fluctuations, and the cosmic, swelling with dark energy. We've also seen space permeating matter in atoms. It is clear that space is not a passive backdrop. It's dynamic and rich. Let's recap our journey so far in simpler terms. Gravity taught us that space is flexible. It can bend, fold, and ripple. Relativity taught us that space and time are united. Quantum physics taught us that space is restless at small scales. It's never truly empty. Modern cosmology taught us that space can expand and carries a mysterious energy in its very form. And everyday life and atomic physics taught us that even seemingly solid matter is mostly space inside. Now, with these insights, consider what space really is. It's not empty. It's the very medium of existence. Space is the canvas on which the masterpiece of the night sky is painted, and also the paint and pigments in that masterpiece. It is the medium through which light travels, and also an actor that shapes the story. By bending light, for example, as in gravitational lensing, where space curves around a massive galaxy cluster and bends the light of more distant galaxies into arcs. Space is the connector between distant objects, the silence that allows a conversation via light or gravity to happen across cosmic distances. Space is the stage on which all cosmic drama unfolds, and yet it is also an actor, shaping the plot with its curves and expansions. It is the ocean on which galaxies sail and the gentle tide that carries them apart. Space is a teacher of humility. It shows us that even what seems empty can hold unimaginable power and significance. It reminds us that absence can be potent, that silence can speak volumes. The stillness of space, which once seemed like nothingness, in fact contains the code that dictates the evolution of the entire universe. When we consider the scale of space and how much of everything is made of it, we might feel small, but there is comfort in it too. Space is a comfort in its constancy. It's been here since the beginning and will be here long after the end of all things. When we feel overwhelmed by our day, we can look up and remember how vast and enduring the universe is. Our worries shrink in the face of that perspective, not to trivialize them, but to soothe us with the knowledge that we're part of something much larger and older, where many troubles have come and gone under the eternal sky. Even our ignorance, like the mystery of dark energy, is a kind of tribute to how subtle and profound space is. It's astonishing to realize that only a century ago, we didn't know any of this. We thought the Milky Way was the entire universe, and we believed space was just an empty void that played little role. Now we've learned so much, that the universe is expanding, that space and time bend, that there are countless other galaxies, that space can erupt with virtual particles and drive cosmic acceleration. Each discovery has only deepened the wonder. Knowing that space can ripple and boil and propel galaxies doesn't take away the magic of the night sky. It adds layers of awe to it. The more we comprehend, the more we appreciate how extraordinary it all is. Finally, let's ponder one more speculation that stretches our imagination to the limit. The possibility that our universe's space is not the only space. Could it be that beyond the observable universe, or in dimensions or contexts we cannot see, there are other universes, other expanses of space-time, disconnected from ours? In other words, a multiverse. This idea is highly speculative, yet many scientists consider it plausible given certain interpretations of cosmology and quantum theory. One scenario arises from cosmic inflation, the extremely rapid expansion that likely occurred fractions of a second after the Big Bang. Inflation might not have ended everywhere at once. It could be bubbling continuously, even today, in distant realms beyond our horizon. Each bubble that inflation drops out would become its own universe with possibly different properties. Our universe would be one bubble among potentially countless others in a frothing metacosmos. To visualize this, imagine stepping outside our universe, a mind-bending thought, and looking at a larger sphere of reality. You might see an eternally expanding space like boiling water, with bubbles forming here and there. Each bubble is a universe, perhaps with its own galaxies and laws of physics. Ours is just one bubble that happened to inflate and then slow down, allowing stars and galaxies to form. Some bubbles might remain forever separate, carried away by relentless inflation in between. Others might occasionally collide, potentially leaving subtle imprints. People have even searched our sky for patterns that could be from a collision with another universe bubble, though none has been confirmed. In this view, reality is far grander than what we can see, a multiverse of universes. Another multiverse concept comes from quantum mechanics, the many worlds idea, where every quantum event splits reality into multiple branches. In that interpretation, there is a vast ensemble of parallel outcomes, parallel universes coexisting in a larger quantum reality. If true, There might be another version of you in a parallel world where some decision or event went differently. This is a different flavor of multiverse, more about layers of reality stacking on the same space rather than separate bubbles of space. But it underscores how space might be part of a much larger tapestry. Whether through cosmic inflation or quantum many worlds or other ideas, like perhaps a cyclic universe that periodically resets, the multiverse remains a hypothesis. We have no direct evidence of other universes. We may never have. It is a mind-expanding possibility, essentially suggesting that what we used to call the universe, meaning everything, might be just a tiny piece of an even vaster existence. If it's true, it's the ultimate Copernican revolution. Not only are we not the center of the universe, but our universe might not be the only one of its kind. Just one bubble in an endless foam. Such a concept can be daunting, but it can also be oddly comforting. It would mean creation is endlessly fertile. That reality tries every possibility, that somewhere, everything that can happen does happen. It also could provide an answer to that question of why our universe has the conditions it does, why the constants of nature are fine-tuned for life. If there are countless universes with varying conditions, we naturally find ourselves in one of the rare universes that is compatible with observers like us. In a multiverse, our hospitable cosmos isn't a 1 in a billion fluke so much as an inevitability among infinite tries. We should stress that the multiverse is still speculative. It's an idea, albeit one that arises from serious physics theories, but we have yet to find a way to test or observe it. It remains a tantalizing possibility on the fringes of our understanding. Whether true or not, just contemplating it broadens our perspective even further. It tells us that space, that fundamental thing we've been exploring, might come in an endless variety of forms across different universes. Perhaps some universes have more dimensions of space, or different kinds of particles, or maybe no matter at all, just endless empty space-time, expanding or contracting. The possibilities are endless. Even if the multiverse remains unproven, thinking about it does one certain good. It underscores just how precious our particular universe is. We have this vast cosmos to explore and understand, full of wonders like those we've discussed tonight. We might be essentially alone, with no other universes ever reachable, or we might be one among billions. Either way, our task and our joy is to know our universe as deeply as we can and find our meaning within it. Now, let us gently return to where we began, to the simple stillness of the night and the feeling of space around us. After journeying through curved space-time and quantum foam, across the cosmos and into the atom, we come back to ourselves, lying here under the sky, whether literally or in our mind's eye, quiet, at peace, and maybe a little wiser. The night is still as it was, but we are not the same. The darkness holds more meaning now. We can sense, behind the silence, the faint echoes of all those phenomena we've talked about. The whisper of space-time, the hum of the quantum vacuum, the faint pressure of dark energy, the quiet spaciousness within our very cells. The stillness around us resonates with the knowledge that it is not an empty stillness at all, but full of structure and story. Space is not empty. It's imbued with the fabric of existence. It connects everything to everything else. In this darkness, the light from distant stars travels. The space allows it to move at the fastest speed possible. The gravity of the Earth extends through space to tug on the moon. Fields, like the electromagnetic field, permeate space and allow radio waves, visible light, X-rays, all forms of light to propagate. Invisible geomagnetic fields from Earth reach out into space around you right now. Space truly is the medium in which all things exist, and through which all interactions occur. If it were somehow removed, all those interactions would vanish, and nothing could happen or even be. Consider some of the roles of space we've encountered. Space is the canvas on which galaxies paint their grand designs, and also the weaver that curves and folds itself to create gravity's effect. Space is the nurturer of structure. Its quantum fluctuations seeded galaxies, and its expanses gave them room to grow. Space is the arena of all history. Every event that has ever happened, from the birth of a star to the firing of a neuron in your brain, took place in space-time. Space is the ultimate connector. When you touch a loved one's hand, it's the space and electromagnetic force fields in that space, between the atoms of your hand and theirs, that communicates the pressure and warmth. Space is a teacher. It teaches us that what appears empty can be full, that absence can have presence. It is a guardian of the universe's secrets, hiding dark energy within itself, keeping the ultimate fate of the cosmos in its hands. And space will be the stage for the universe's far future. Looking trillions of years ahead, one can envision a time when space will be virtually all that remains. As the eons pass, galaxies outside our local group will drift farther and farther away, eventually vanishing beyond the horizon, their light stretched into oblivion by the expanding space. The night sky will grow emptier as distant stars disappear from view. Trillions of years from now, even the stars in our own galaxy will exhaust their fuel. One by one, they will wink out, leaving behind faint embers, white dwarfs, neutron stars, and black holes. These remnants will gradually cool and evaporate, in the case of black holes, via Hawking radiation, over an incomprehensible span of time. The universe will continue to expand and cool toward a state of almost complete darkness. In that far future, no new stars are born. No bright galaxies light up the sky. What remains is largely space itself. Vast, cold, nearly empty, studded only sparsely with subatomic particles and the fading whisper of photons from long ago starlight. And yet, through it all, space endures. The same fabric of space-time that was there at the fiery birth of the cosmos will still be there in that silent twilight eons hence. The stage persists even after the actors have left. Perhaps that will be the final chapter of our universe. An ever-expanding dark volume of nearly pure space, quietly extending into eternity. Perhaps, someday, quantum fluctuations within that nothingness might seed a new Big Bang, a new universe, a speculation in some cyclic cosmologies. But either way, the legacy of space is that it is the last cosmic witness. When all else has come and gone, space will still be here, silent and waiting, as it was in the beginning. Space is, in a sense, the alpha and omega of the universe, present at the start, shaping everything in between, and remaining at the end. Now, back to this moment. The night is deep and beautiful. The quiet around you, this gentle void, is the same entity we've been contemplating in all those extraordinary ways. Let that sink in. The empty air and space enfolding you right now carries the heritage of the entire cosmos. It carries the gravity that holds you to Earth. It carries the starlight that reaches your eyes. It carries the potential for future worlds and the echo of the very birth of the universe, a faint whisper of microwave background that bathes all of space, even now, at about 2.7 degrees above absolute zero, giving the night a slight warmth. This space around you is part of the same continuum that bends around a black hole and expands between galaxies and buzzes with vacuum energy. You are deeply connected to the universe through space. You always have been. It's impossible to be truly isolated because the fabric of space links you to the furthest galaxy and the smallest atom. When you look at the stars or simply breathe the night air, that connection only becomes more apparent. You are a child of space, born from stardust that coalesced in space, sustained every second by the oxygen and photons traveling through space. And ultimately, when you return to dust, your particles will drift in space again. Bask in that realization. You belong. You belong here in the universe, and it belongs in you. The boundary between you and out there is not a wall, but a porous membrane constantly exchanging matter and energy. You inhale the atmosphere, drawing in molecules that might once have been exhaled by ancient trees or dinosaurs, and ultimately originated in cosmic processes. You exhale, and your breath's atoms eventually mix into the sky and beyond. In a physical sense, you are never separate from the universe. You are always in communion with it. Take another slow, gentle breath. Feel the cool air fill your lungs, and know that even that simple act is an interaction with space. As the air spreads in your lungs, it's essentially molecules finding room in the internal space of your body, delivering oxygen to your cells across microscopic gaps. As you breathe out, you're releasing carbon dioxide that will travel through the atmosphere, maybe feed plants, maybe one day waft into the upper sky and beyond. Through you, the Earth and space are linked. Now, you have permission to let go of all these thoughts if you wish. You don't need to actively think about curvature or quantum foam or dark energy anymore tonight. The knowledge is there, settled gently in the back of your mind, enriching the way you feel the night. You can simply relax in the feeling of it, the feeling of being part of this vast, ongoing cosmos. Above, the stars continue to shine, distant and silent. Around, the darkness remains calm and embracing. You might sense in your own body a mirror of the cosmos, the rise and fall of your chest like the expansion of space, the circulation of blood like galaxies drifting in their clusters, the neural flashes in your brain like tiny starbursts. In the stillness, you can almost feel the subtle humming connection between your life and the wider universe. You are safe. You are weightless and free. The quiet of space enfolds you like a warm blanket. Feel how the whole universe supports you in this moment. The ground beneath you, the air around you, the sky above. You belong here. You are part of all this. There is nothing you need to do right now except be. Just exist. Just rest. Inhale the stillness. Exhale any worry. Let yourself float on the calm of the cosmic ocean. You are safe. You are embraced by existence. You are at peace. No matter where you go, you carry this home of space with you. It was there at the first moment of your life. It sustains you each day, and it will remain long after we are gone. The stillness that surrounds you is the same stillness that cradled the young universe and that will hold the final stars as they wink out. You are truly home in this stillness. It is the cradle of everything. All the understanding we've gained about gravity, time, quantum foam, expansion, and so on leads to a simple, profound truth. Space is not empty. It is everything. It is the foundation and framework of existence, and you are not separate from it. You are one with it. An expression of the universe, a part of space becomes self-aware. When you gaze at the night, the universe is gazing back at itself through your eyes. So rest now, gently, in the embrace of space. Feel the deep peace of knowing that you are held by the same darkness that carries the stars. The infinite extends around you, quiet and caring. Let go of any remaining tension. Let it fall into the vast well of calm that is space. Let your thoughts drift like gentle clouds across the sky of your mind. No need to chase them. They can float away into the darkness, leaving you calm and clear. You are safe. You are weightless. You are free. The endless silent universe enfolds you, and you belong to it. You are a part of it all, and it is a part of you. In this profound unity, you can release all fears and rest. The night is very quiet now. Around you, the earth sleeps, and the cosmos watches in patient silence. Feel your heartbeat slowing, peaceful. A tiny clock kept by spacetime within you. Feel your breaths becoming soft and rhythmic, the same rhythm that pervades all of nature. There is no rush. Time flows at its own gentle pace. Space provides limitless room for your dreams to unfold. You are home in the universe. You are never alone. The space that fills your room, your lungs, and your heart connects you to the furthest galaxy and to the beginning of time. In this knowledge, you can truly rest. All is tranquil. All is as it should be. Stillness. The stars shine. The galaxy slowly turns. The universe breathes in and out on timescales far beyond comprehension. And here, in this quiet moment, you breathe softly, in unison with the cosmos. The stillness of space is within you and around you. Let it lull you into a deep and gentle sleep. Feel yourself drifting, weightless, on a calm, cosmic sea. There is nothing to fear in this dark. It is the same darkness that gave birth to the first dawn. There is everything to love in this silence. It carries the echoes of creation and the promise of eternity. You are safe. You are connected. You are at peace. Sink deeper now into the comforting dark. The universe holds you like a parent cradling a child. The ground beneath you, the sky above, all is one with you. Your mind is quiet, tracing the outlines of these truths with a final, drowsy sense of awe. What remains is not calculation or analysis, but a simple reverence for existence. In the grand sanctuary of space, you close your eyes, your breathing slow and steady. The boundary between yourself and the night dissolves. You are the universe, and the universe is you, a wave returning to the ocean of space. Rest now in that knowledge. Rest in the arms of the cosmos. Feel the profound stillness, the gentle, omnipresent support of space beneath you, holding you up as it has held up worlds and suns and galaxies. Let that stillness fill you. There is nothing more to do, no more striving needed. Just be. Just let yourself go, like a leaf floating on a vast dark pond, carried by the calm currents. Space will watch over you. It has always watched over everything. Your mind is calm. Your body is relaxed. The stars continue their silent vigil overhead, and you drift closer to sleep, carried by the same silence that spans the light years. The feeling of space, that stillness, that openness, that gentle cradle of all things is all around you, and it soaks into your very bones. In this moment, you are that stillness. There is no separation. Quietly, the universe whispers you a lullaby in the language of silence. It says, "You are home. You are home." Let yourself drift in this infinite peace, stillness, silence, space. The journey is complete. The knowledge is within you. The stillness is everything. You are a child of the cosmos, and the cosmos is kind. Feel its love in the quiet of the night. Space is not empty. Space is everything. And you, your atoms, your mind, your life, you are part of that everything. You always have been and always will be. In the great dark between the stars, there is comfort and belonging. In the stillness here, there is the embrace of the infinite. Be at peace, dear traveler of the universe. You are home in the stars and the night. The space around you is your space. The silence around you is your silence. Nothing separates you from the whole. You are safe. You are loved. You are one with the deep, eternal stillness of space. Rest now in that eternal stillness. Let the quiet carry you into restful sleep, as gently as a mother rocks a baby, as naturally as night becomes dawn. The universe holds you. Stillness, silence, sleep. Good night, child of space. The cosmos within and around you watches over you, now and always. Stillness. Space is silent. High above the clouds, beyond the reach of any breath of wind, there is an expanse
unlike any on Earth. As you ascend beyond the blue sky, the air thins to nothing. The soft whisper of atmosphere falls away until all around you is an endless black. This is space, not an empty void, but a new kind of place, a vast expanse defined by the absence of what we take for granted. Without air, there is no sound, no gentle tone or rumbling thunder. Even a shout would vanish unheard. In this silence, your own heartbeat might be the loudest thing you perceive. Out here, a single breath of air is precious, contained within a spacesuit or a ship, a fragile bubble of warmth amid a limitless cold. Remove that protection for an instant, and the vacuum rushes in. Your breath would be stolen, water in your eyes would boil into vapor. There is no mercy in a vacuum. It is a realm that does not welcome life, yet it calls to us with its stillness and its mystery. Look around. With no atmosphere, day and night are divided only by the sun's light or its absence. In sunlight, there is a harsh brilliance. The sun's rays, no longer filtered by layers of air, pour down unsoftened. Light in space is piercing and pure, turning metal surfaces blindingly bright and casting shadows sharp as a knife's edge. But just a few steps into the shade, there is a profound darkness and a bitter cold. There is no air to carry warmth from light to dark. Touch one hand to a surface in the sun, and it burns hot. Touch another in shadow, and it freezes. In space, heat and cold live side by side, extreme and unmoderated. Yet in this darkness, countless stars glow. They do not twinkle as they do from Earth. Instead, each star's light travels across the void unhindered, a steady pinprick in a black velvet sky. With no air to bend their light, the stars shine unwavering and clear, and beyond the stars lies an even fainter glow, the soft background of the universe itself, a memory of the fires that forged everything long ago. Space may be dark to our eyes, but it is never truly empty of light. Motion itself behaves differently here. Imagine releasing a small object, a tool, a glove, into this void. Without air resistance to slow it, without ground to stop it, that object would drift on and on, potentially for eternity, unless something intervened. In space, an object in motion remains in motion, gliding endlessly along a straight path or orbiting under the guidance of gravity alone. Here, Newton's laws reveal their pure form. Nothing will come to rest on its own. A single push can send you floating, and only another push or the tug of some distant gravity will alter your course. Gravity still weaves its influence even in what seems like emptiness. There is no place in the universe truly free of it. Invisible lines of gravity link you to Earth, to the moon, to the sun, and beyond. In fact, you feel weightless, not because gravity has vanished. Earth's pull at your altitude might be only a little weaker than at the ground, but because you are falling freely, caught in Earth's gentle grip as you circle around it. This free fall produces a sensation of utter freedom. Without up or down, you drift as though in a dream. If not for the confines of your spacecraft, you could tumble endlessly, with only the distant stars as your reference. Even time itself dances to a new rhythm here. The presence of mass and gravity affects the flow of time, ever so slightly. Far from Earth's surface, where gravity is weaker, time ticks ahead a touch faster than at home on the ground. A clock carried into orbit will gain a few fractions of a second over one left on Earth during a long mission. It is a tiny difference, imperceptible to a traveler, yet it whispers of a profound truth. Space and time are intertwined. Gravity, the force that holds planets in orbit and pulls us to the ground, stretches and squeezes the fabric of time itself. In the depths of space, far from any massive body, an hour might pass just the slightest bit differently than an hour under Earth's blue sky. All these conditions, silence, weightlessness, stark light and shadow, and the bending of time, define the environment of space. It is not a mere void. It is a canvas on which the universe paints with forces and light. It is a place where our intuitions falter, where a feather and a hammer dropped together will fall side by side in the absence of air, where the horizon is the curve of a planet far below, and where the only sounds are those we carry with us. This is the arena into which humanity cast its dreams, yearning to explore despite the danger and the emptiness, or perhaps because of them. In this silent expanse above the sky, one feels both incredibly small and indescribably free. The Earth is below, a bright and colourful presence, and beyond is the infinite night. To stand at this threshold is to sense the true scale of things, a vast cosmos stretching out in all directions, and our home a delicate sphere suspended in its midst. Space is the great beyond that begins just a few dozen miles above our heads, yet for most of history it remained unreachable. It waited, quiet and patient, for the day when we would find a way to slip through the sky and enter its realm.
And when at last we did, when the first fragile craft carried life into this void, we began a new chapter, leaving the familiar air of Earth for the strange wonders above.
It began with a single brave step beyond our world. The first foray was not a person, but a machine, a tiny silver sphere launched into orbit, circling Earth with a faint radio pulse. Humanity held its breath as that artificial moon passed overhead, a moving star that carried our hopes into the night. Its signal was a simple beep beep, but it spoke volumes. We had reached space. The cradle of Earth had opened, and something made by human hands was now falling around the planet like a new moon.
Soon after came the milestone that once seemed like science fiction turned reality. A human being ascended into the cosmos. Strapped into a cramped capsule atop a roaring rocket, a lone explorer left the ground. Imagine the violence of launch, the shaking, the crushing force of acceleration, the thunder of engines pushing against Earth's gravity. For a few minutes, the rocket raged, fighting to escape the pull of home. And then, suddenly, there was quiet. The engine's roar ceased, the shaking stopped. The capsule floated free, coasting above the atmosphere. In that moment, for the first time in history, an Earthling was orbiting Earth, surrounded completely by the void of space. Inside the spacecraft, the astronaut unstrapped and began to float, the first experience of true weightlessness for a human. What a mix of emotions he must have felt. Exhilaration, awe, perhaps a touch of fear. Through a small window, he could gaze at the world he had just left. He saw the curving horizon of Earth, the colors of oceans and land far below, the swirls of clouds over the surface. Along the edge of the planet, he made out a thin, glowing band of blue, the atmosphere, our fragile veil of air shining in the sunlight. From up here, it looked so delicate, a wispy halo holding in all the air, all the life, everything everyone has ever known. Beyond that blue edge was the black of space stretching infinitely. He radioed back descriptions of what he saw. The Earth was beautiful, beyond any sight imaginable. Floating in that tiny cabin, he watched day turn to night as the spacecraft sped around the globe. In a single orbit, dusk and dawn swept across his view. Sunlight burst over the horizon in a silent sunrise, and on the night side, the cities on Earth twinkled faintly like stars under the darkened atmosphere. In a mere hour and a half, he had circled the entire planet, a journey that once took explorers months upon the seas, now completed in minutes above the atmosphere. The scale of the Earth, the vastness of the ocean below, all became at once majestic and yet contained, reachable. For those watching from the ground, this event was transformative. All around the world, people tuned in to scratchy radio broadcasts or grainy television images, following the journey in collective awe. In that moment,
Many felt a sense of unity. Our species, usually divided by borders and conflicts, was now achieving something together. It was not just one nation's accomplishment. It was a human accomplishment, a triumph for all of us gazing upward. Children looked at the sky with new dreams, imagining that they too might one day ride a rocket among the stars. Elders, who had seen horses give way to airplanes in their lifetime, now witnessed an even greater leap. It felt as if a window had opened in the firmament, and through it we all glimpsed a new destiny. Each new mission built on the last, extending our reach. Before long, more explorers followed. They orbited Earth not just once, but many times, staying in space for days at a time, testing the limits of human endurance in microgravity. And with growing confidence, they performed feats requiring even greater daring. One day, a spacecraft's hatch opened above our planet, and a human being floated out into open space, untethered from any craft except for a single cord. For the first time, a person was truly outside of any vehicle, drifting in the raw nothingness with only a thin suit for protection. He became a tiny satellite of Earth, his body encased in a white suit and helmet, the blue planet turning slowly below his feet. Imagine the mixture of terror and wonder in that moment. To push off into the void, to look down and see the entire Earth beneath you, and nothing but black above. This was a leap into the unknown in the purest sense. His lifeline was literally a line, a tether back to the capsule, his only route home. As he floated, the silence was total, except for the hiss of oxygen in his helmet and the beating of his heart. Every direction he looked, he saw creation on a scale never witnessed by human eyes. The full sphere of Earth, dazzling in sunlight, the countless stars on the night side, the sun cresting the horizon with sudden, blinding light. It was a sight to etch itself into the soul. When he finally pulled himself back inside, it was with reluctance. One spacewalker later said that returning to the confines of the ship was the saddest moment of his life. He had felt so free out there in the emptiness, so awed by the cosmos, that re-entering a small module felt like stepping back into a cage. Such was the powerful draw of the open void and the perspective it granted. These early journeys beyond Earth were brief, hours or days, but their impact on our collective consciousness was immense. Those who went up returned as messengers, struggling to express how profoundly it moved them. They spoke of the spectacular beauty of Earth seen from above, of the thinness of the atmosphere, of the deep loneliness and extraordinary clarity one feels in space. Many struggled to put it into words, saying things like, "I wish I could show you the Earth as I see it. Perhaps then you would understand why we must cherish it." Seeing our planet as just one small, borderless globe adrift in the dark had fundamentally changed them. No borders were visible from space, only the continents and oceans, wrapped in a single shared blanket of air. One astronaut described Earth as a shining oasis in a vast darkness. Others noted how small it looked, and how everything we fight over seems meaningless when viewed from thousands of miles away. This shift in perspective, often called the overview effect, hinted that leaving Earth was not just a technical achievement, but a philosophical one. It forced us to reckon with the unity of our species and the fragility of our home. With each mission, humanity's confidence grew. What began as tentative orbits soon turned into plans to venture further. Our eyes shifted to the moon, that glowing companion in our night sky that had beckoned for millennia. If we could circle Earth, could we travel to our nearest neighbor in space? Fueled by both curiosity and a new sense of possibility, we set our sights on lunar shores. In a bold journey not long afterward, humans left the comforting embrace of Earth orbit entirely. A crew of explorers rode a powerful rocket away from home, their path curving outward until Earth was no longer holding them. For the first time, humans were truly in deep space, crossing the gulf to another world. After days of travel, They felt the gentle tug of the moon's gravity capture them. They had arrived in orbit around the moon. Our first visit to another celestial body. Peering out, those astronauts beheld an alien landscape up close. Vast grey plains and craters on the moon's face just below their spacecraft, stark and lifeless. But it was what they saw when they looked back toward the horizon that took their breath away. Over the moon's bleak horizon, in the black sky, rose the Earth. It was an unimaginable sight, our own world ascending above the lunar landscape, a blue-white marble with swirls of cloud, rising like a delicate gem against the backdrop of space. In that moment, as one of them later reflected, they felt that in going so far to explore the moon, the most important thing they discovered was the Earth. Seeing our entire planet from the distance of the moon, small enough to cover with a thumb held at arm's length, was a revelation. Every ocean, every mountain, every single one of us was on that tiny ball. This image, often called Earthrise, was more than just a photograph. It was a mirror held up to humanity. It showed us how alone we are in the cosmic darkness and how precious our planet is. Many who saw that image felt a surge of emotion and responsibility toward our home world. If Earth was that small and fragile, how carefully we ought to treat it. In crossing the void to another world, we had gained a profound new perspective on ourselves. Not long afterward came the ultimate adventure of that era, the moment human boots touched the soil of another world. A fragile lander descended toward an ancient cratered surface, carrying 2 humans. The world watched with bated breath as it slowly came to rest on the moon. When the first astronaut stepped off the ladder and onto the moon's soil, he left a boot print in the fine grey dust, the first mark of our species on an alien world. One small step, he called it, and indeed, it was small in distance, a couple of feet down a ladder. But in that instant, human civilization expanded beyond Earth for the first time. We became, in a sense, a multi-world species. It is hard to overstate the magnitude of that moment. Through the astronaut's eyes, the landscape was eerily familiar, yet utterly alien. The ground was solid beneath them, yet this world had never known life, or sound, or liquid water. The sun shone fiercely, but against a pitch-black sky sprinkled with stars. There was no air to scatter light or color the heavens. The horizon was much closer than on Earth, curving noticeably only a few miles away, making the terrain feel strangely confined, like standing in the middle of a great shallow bowl. Everywhere they looked, desolation, grey dust, rocks of all sizes, and craters upon craters stretching to the horizon. And above it all, Earth hung in the sky, large and blue and marbled with white clouds. It was so bright and colourful compared to the monotone ground on which they stood. On the moon, the only sounds were those carried internally: the hiss of oxygen in the suit, the thump of one's own heartbeat, the crackle of the radio linking them to each other and to Earth. If they struck a metal tool against a rock, they felt the vibration in their gloves, but heard nothing through the airless environment. The silence was profound and absolute. Every movement they made felt both slow and graceful in the low gravity. Walking became a bouncing lope. Each step propelled them forward much farther than on Earth, and when they jumped, they rose in slow motion. They discovered they could leap quite high with little effort, but also that without air resistance or strong gravity to help them regain balance, even a gentle stumble could turn into a slow tumble. They fell a couple of times, landing with a light puff of dust, unhurt, and giggled at the absurdity of falling in such slow balletic motions. Their footprints formed a trail as they moved about, crisp impressions molded in powdery regolith. Because there is no wind or rain on the moon, those prints might remain for millions of years. Every step was literally inscribed into lunar history. They proceeded with caution and curiosity, aware that they were strangers in a hostile environment. Their white suits, bulky with life support systems, stood out against the grey like ghosts wandering in a silent dream. Above their heads, golden visors shielded their eyes from the unfiltered sunlight. Behind those visors, their eyes were wide, taking in the marvel of every rock and crater. Each stone they picked up was likely older than any living thing on Earth. Each hill was shaped by impacts eons ago. They trod carefully, almost reverently, on this primordial ground. Mingled with awe was a sense of duty and discovery. These astronauts were not just explorers, but scientists and ambassadors of all humanity. They began to collect samples of the lunar soil and rocks, scooping and hammering and bagging pieces of the moon to take home. The soil was like fine charcoal grey powder, clinging to everything, even to their suits, due to its texture and the static charge from the sun's radiation. It smelled faintly of burnt gunpowder when they later took off their helmets, a curious detail they noted. They deployed instruments, a seismometer to listen for moonquakes and meteor strikes that would reveal the moon's inner structure, and a laser reflector that would allow precise measurement of the distance between Moon and Earth for years to come. Each task was performed deliberately. Movements that would be simple on Earth took more time here. Handling tools while wearing pressurized gloves was clumsy, and the lack of weight could be both a help and a hindrance. A heavy hammer swung easily, but when they tried to drive a core tube into the ground, they had so little weight to push down with that it was tricky. They worked around these challenges with ingenuity and patience. From time to time, they paused and simply looked around. Imagine standing on the moon with them, an aching emptiness all around under a black sky. No sound, no breeze, just the sharp contrast of light and dark. In sunlit areas, the ground was glaringly bright. In shadows, it was inky black, as the sunlight does not scatter. The temperature contrasts were extreme. Their suit's exterior in the sun was hot, while parts in shadow were freezing. But the suits kept their bodies comfortable, a bubble of earthly climate strapped to their backs. They glanced up at Earth frequently. It was comforting and jarring at once to see that distant sphere, their home, hanging above the horizon, alive with color and motion, in stark contrast to the dead world under their boots. Earth appeared about 4 times the size the moon looks from Earth's sky. They could make out white swirls of clouds, blue oceans, the brown-green of land masses. Knowing that everyone they had ever known was on that tiny globe overhead filled them with a profound sense of connection and also of loneliness. They were farther from home than any humans had ever been, and yet never had home looked so beautiful. Back on Earth, nearly 1 billion people watched or listened as humans explored the moon. Cities paused as people crowded around television sets in shop windows, school auditoriums, and living rooms. When the astronauts spoke from the moon, so many listened that some later said you could walk down a street and not miss a word, as the broadcast echoed from house after house. Seeing fellow humans on another world struck a chord deep in everyone. In many languages and many nations, prayers, cheers, and tears flowed simultaneously. For a short while, humanity was united in awe and aspiration, living through the footsteps of a few. The explorers left on the moon certain tokens of humanity, scientific instruments, and flag they carefully planted and propped up to appear as if waving, and a plaque on the lander's leg with a simple message of peace and all humanity. They recognized that their achievement belonged to all people of Earth. They spent a few precious hours on the lunar surface, fulfilling their duties and satisfying a bit of their own curiosity. All too soon, it was time to depart. They had to return to their lander and prepare to leave this quiet world. With them, they carried bags of lunar rock and dust, the first samples ever collected from another planetary body, treasures that scientists would study for decades. But something else intangible would return with them, a new perspective, a new chapter in human experience. Before climbing the ladder back into the module, one astronaut paused and looked out at the horizon one last time. He imagined future travelers standing where he stood,
perhaps building habitats, perhaps even being born under that black sky. He knew that although they must leave now, humanity would likely return, driven by the same wonder that brought them here. The ascent module's engine fired, and in a burst of smoke and spark, it rose from the moon, leaving the lander's base and those iconic footprints behind. As the astronauts ascended to rejoin their colleague orbiting above, they watched the dusty surface fall away beneath them. Through a small window, they saw their landing site shrinking, the flag and experiments now mere dots, their own tracks indistinguishable. An entire world, which moments ago surrounded them, had now become a landscape below, and soon would be just another feature on the moon's face. They rendezvoused with their orbiting mothership, transferred the precious samples and themselves aboard, and bid farewell to the moon. The journey home was quiet and contemplative. As Earth grew larger in their window with each passing hour, they reflected on what they had accomplished. They were tired, exhilarated, and forever changed by the experience. They had stood on the dust of another world and gazed back at the entirety of humanity's home. They carried with them not just data and rocks, but stories and insights that would inspire generations. When their capsule blazed through Earth's atmosphere days later and parachuted into the ocean, the world celebrated. The explorers were safe and home. They emerged from their charred vessel to the blue sky and warm air of Earth, to a world that suddenly felt both comforting and strangely heavy. As they took their first breaths of fresh Earth air and felt the full weight of their bodies return, they realized how heavy gravity can feel after days of lunar lightness. They were helped onto a ship's deck as heroes, but in their own hearts, they felt more humbled than triumphant. For they had seen how lonely our shining planet is in the cosmic night, and how blessed we are to have it. The moon landings marked a pinnacle of human exploration in that era. We had touched another world and proved that even the most daring dreams could be made real. Beyond the scientific discoveries, learning that the moon shares a common origin with Earth, that it is lifeless and ancient but holds clues to our own planet's history, there was a shift within us. Standing on the moon, humans realized viscerally that we are citizens of the universe, with the ability to move beyond our cradle. The achievement echoed through culture, art, and philosophy. It suggested that if we could journey to the moon, what else could we do? And it begged the question, where shall we venture next? After the moon missions, focus swung back to living in space near Earth for longer periods. We had proved we could visit another world. Now we needed to learn how to endure away from Earth. Thus began the era of space stations and long-duration flights, which would prepare us for journeys to more distant worlds like Mars. What was once a brief adventure, just a few orbits or days beyond Earth, evolved into something more enduring. In time, humanity learned not just to visit space, but to live there. We built our first outposts in orbit, space stations, essentially homes and laboratories circling high above Earth. These were places where astronauts could stay for weeks, then months, experiencing life without gravity and conducting experiments in a way never possible on the ground. Aboard an orbital station, the routines of day-to-day existence took on a new form. Imagine waking up in space. There is no dawn through a window in the traditional sense to gently brighten your bedroom. On a station, the sun may have risen and set several times during your sleep. Orbiting Earth every 90 minutes, the station experiences about 16 sunrises and sunsets each Earth day. To keep their sanity and health, astronauts impose an artificial rhythm. They follow a 24-hour schedule, much like on Earth. Morning is declared by the clocks, not by the sky. The crew wakes at what would be morning back home, even if outside their window the sun might be blazing or the stars might be visible. The first tasks are simple things made strange by weightlessness. An astronaut unzips her sleeping bag that is tethered to the wall of a small crew cabin. She doesn't climb out of bed. She floats out. All night she has been gently strapped in place. Otherwise she might have drifted around the module in her sleep. In microgravity, there is no up or down, so she might have slept upright or upside down relative to how a room is oriented. Her body doesn't mind. She feels rested, though some crew members say sleep in space can be fitful until one gets used to the constant background hum of fans and the lack of the usual weight on your body. In space, your spine stretches a bit without gravity, and you wake slightly taller than when you went to bed. She moves through the station by pushing off with a fingertip, gliding down the corridor like an underwater swimmer. Every surface is usable. What would be a ceiling on Earth can serve as a floor or wall here. Floating and maneuvering in microgravity becomes second nature after a few days. Astronauts learn to orient themselves any which way. One crew member might hover sideways, another upside down as they chat, hardly noticing the difference. Morning hygiene requires ingenuity. There is no shower to step into. Water in 0G would not obediently flow down into a drain. Instead, she uses a damp cloth and no-rinse shampoo to wash her hair, which fans out in all directions without gravity to make it lie flat. A blob of water squeezed from a pouch floats in front of her, like a quivering liquid pearl, until she catches it on the cloth. She brushes her teeth with edible toothpaste because spitting is tricky when everything floats. Every drop of water is precious, so the moisture from her breath and sweat will be captured by the life support system, filtered and turned back into drinking water. Even the simple act of using the toilet is an elaborate process. A special seat and a gentle airflow to guide waste where it needs to go. It's perhaps not the most poetic aspect of life in space, but a vital one that pioneers have mastered with clever engineering. After dressing, tugging on fresh clothes is easier when you don't have to balance. She drifts to the galley for breakfast. Meals in space are often stored in packets, some dehydrated and needing a bit of hot water added, others ready to eat in pouches. She might have scrambled eggs rehydrated from powder and coffee, sipped through a straw from a sealed bag. Without gravity, she can't pour coffee into an open cup. It would break into floating globules. In fact, liquids and food crumbs can be a nuisance, drifting away and potentially getting into equipment, so everything is carefully contained. The crew velcros their food packages to a table or snaps them into place so they don't float off while eating. If a stray morsel does escape, someone will snag it out of the air before it wanders off like a tiny lost planet. Once breakfast is done, the astronauts get to work. A space station is both home and laboratory, and every day is filled with scheduled activities. They might begin by checking on experiments that ran overnight, perhaps a chamber where crystals are growing larger and more perfectly than on Earth, or a small greenhouse where plants stretch their leaves in microgravity to see how they develop. In another rack of equipment, there could be living cells multiplying in culture, or tiny aquatic organisms swimming in circles, all observed to understand how life responds without gravity's pull. Other experiments involve physics and materials, melting alloys to see how they mix without gravity's influence, or observing how fluids behave when they aren't pulled down by weight. On Earth, flames rise and flicker, but here, a flame forms a small blue orb, glowing steadily as it consumes oxygen in all directions evenly. The astronauts become the hands and eyes of scientists back on Earth, running these experiments and recording data. Maintenance is another crucial part of the day. A space habitat is a closed bubble that requires constant care. Filters need to be cleaned. Carbon dioxide scrubbers, which remove the CO2 the crew breathes out, need to be monitored. The water recycling system needs regular checks. They inspect equipment, tighten bolts, update software. Every so often, something might break, perhaps a pump or a circuit, and the crew springs into action to fix it with the tools and spares on hand. In microgravity, a dropped screw doesn't fall to the floor, it floats away, so they must be meticulous, keeping track of every component. Working in weightlessness has advantages too. A heavy panel that would normally require 2 people to lift can be moved with a fingertip push. But the lack of gravity can complicate tasks that on Earth are made easier by being able to brace your feet on the ground. Astronauts often have to strap their feet into footholds or use handholds to anchor themselves while turning a wrench so they don't push themselves away with each twist. Around what would be midday, they pause for lunch. They might gather near a window. Space stations are equipped with viewing ports to eat while gazing down at Earth. Imagine that view. Far below, the planet rolls past. One moment a broad sweep of ocean with sun glinting off the surface. The next moment coastlines and islands coming into view. Later in the orbit, perhaps deserts of deep red and orange slide beneath. Then the green tapestry of a rainforest. At night, they see the flicker of thunderstorms, bright bursts of lightning illuminating cloud tops, and the gentle glow of city lights outlining the continents like luminous constellations of humanity. The sight is mesmerizing, a constant reminder of why they endure the challenges of this environment. An astronaut might point out to her crewmates, "We're crossing over our home country now," and they all crowd the window for a moment, watching familiar lands drift by, tiny and silent from space. Discipline calls them back to work. The afternoon might include a video conference with mission control, teams of people on Earth who support the mission, going over plans, troubleshooting any issues, and sharing news from home. Though far away, the crew is never truly alone. Radio waves keep them connected, and they can talk to engineers, family, or even school children by radio, carrying voices across the void. One crucial appointment each day is exercise. In microgravity, without the constant pull of Earth, the human body begins to weaken. Bones lose calcium, muscles shrink, and the heart doesn't have to pump as hard to circulate blood. To fight this, astronauts must work out rigorously, usually about 2 hours a day. Our astronaut changes into exercise clothes and moves to a special treadmill. She straps herself down with bungee cords to keep her feet on the belt. Otherwise, she would float away with each step. As she runs, sweat forms into droplets on her forehead. There's no breeze to cool her. A fan in the treadmill unit helps pull the moisture away. It's a strange sight, running while essentially being pulled to the machine, but it keeps her body strong. Others use a stationary bicycle with Velcro straps to hold their feet on the pedals, or a resistance machine that mimics weightlifting by using vacuum cylinders or elastic bands for force. This daily routine of sweating and strain is vital. Without it, returning to Earth's gravity would be much harder on their bodies. Even with exercise, astronauts returning from 6 months in orbit often need help standing at first, and their bone density might be reduced. But the workouts significantly mitigate these effects and keep them healthy far from home. By late afternoon, the crew is wrapping up experiments and maintenance. They might record a brief video diary, documenting their experiences for scientists and for posterity. In the calm of evening, there's often a little free time. Perhaps our astronaut floats to the largest window, a cupola with panoramic glass, and simply watches. This is a favorite pastime of many who live up here, to gaze down at the planet, watching the dance of auroras at the poles or the thin line of atmosphere glowing at sunset. In these quiet moments, it sinks in that they live in a place where day and night are a matter of perspective, and that below them billions of people go about their lives unaware of the silent station passing overhead. She might take photographs to share this view with people on the ground, capturing the gentle curvature of Earth or the delicate veil of air encircling it. Some evenings, astronauts gather for a shared meal or a bit of leisure. They might play a guitar that's kept on board, strumming music that echoes softly through the modules. A gentle concert with no gravity, where the notes carry differently in the thin air. Or they might pull out a favorite book, reading while drifting comfortably in mid-air. Laughter still occurs in space. Jokes are told. Camaraderie is formed. They show each other family photos taped to the walls of their small sleeping berths, or play a quick game of cards using Velcro patches to keep the cards from escaping.
They celebrate birthdays by baking, in a small food warmer, a special treat, or by sharing a pouch of dessert sent up from Earth. The station might be far away, but human culture and warmth travel with the crew. Finally, it's time for night on the station. The sun may still rise again soon outside, but the crew follows the agreed schedule to maintain their circadian rhythm. They close the shutters on the windows to dim the interior and turn down the lights. Each astronaut retires to their personal little cabin or sleeping nook, a closet-sized compartment just big enough for a sleeping bag, a laptop, and a few personal items. Our astronaut slips into her sleeping bag and zips it up, attaching a couple of straps that prevent her from drifting out of place. She might listen to some calming music or write a few lines in a journal about the day. Then she turns off her lamp. In the darkness, she is weightless. There is no bed to press against her. She floats in a gentle embrace of the sleeping bag. It can feel like drifting on a cloud. If she peeks out through a small window before closing her eyes, she might catch a glimpse of Earth's limb, illuminated by moonlight, or a field of stars not blinking, steady and cold. As the station moves along its perpetual orbit, the astronauts aboard slip into slumber one by one. Their bodies rest, still gliding around Earth at thousands of miles an hour. The rhythm they follow is of their own making, a harmony between human life and the mechanics of an orbital path. Outside, the universe remains silent and dark, but inside, there is the soft sound of breathing and the whir of fans, a reminder that even here, in the domain of vacuum and stars, humans have made a home. The routines of space, both extraordinary and strangely routine, carry on. And as one day in space ends, another is already beginning, with the sun rising once more beyond the shutters, ready to greet the crew when they wake. Living in orbit became almost ordinary in its miraculous way. What once was the subject of wild imagination, floating inside a ship high above the Earth, became a continuous human presence. Year after year, astronauts swapped places. New crews arrived as others departed, so that there was always someone living off Earth, even if only a few at a time. This new normalcy of orbital life was a testament to how far we'd come. We learned how to eat, sleep, work, and laugh in a place utterly alien to our evolution. We took a tiny piece of Earth, our culture, our bodies, our need for connection, and transplanted it into the skies. Yet, as comfortable as one can become floating in a tin can above the world, the human spirit still yearned to go further. Our first home in space was a marvel, but it still orbited the Earth we knew so well. Beyond our station's path lay the moon, beckoning again, not just for short visits, but for longer stays. And beyond the moon, the ruddy dot of Mars captured our imagination. The experience of living in orbit was preparing us for greater journeys, teaching us how to survive outside Earth's cocoon for long periods. It was time to turn that knowledge toward new horizons, toward the cratered plains of our nearest neighbor and the distant deserts of the red planet. The moon, goal of ancient dreams and recent triumphant footsteps, began to draw our focus once more. This time, the aim would be not just to land briefly, but to stay. Humanity's first outpost on another world, a lunar base, was envisioned on the not-so-distant horizon. Engineers and visionaries sketched plans for habitats on the moon's surface, perhaps near its south pole, where sunlight and shadow dance in useful ways. Sunlight to provide power on mountaintops that bask in eternal day, and shadow in nearby craters that harbor deposits of water ice in the dark cold. A treasure for life support and fuel. After the moon, Mars waited farther afield, the planet most like Earth in our solar system, yet still profoundly different and harsh. The idea of sending people to Mars, once just science fiction, started to take concrete shape in plans and prototypes. It was the next logical step, but a far more difficult one. Mars is so distant that a journey can take 6 to 9 months one way. The commitment would be enormous. Anyone who went to Mars would likely be gone for 2 or 3 years at minimum, considering travel time and the alignment of planets needed for a return voyage. Unlike the Moon, which had seen humans come and go, Mars would demand a new level of endurance and self-reliance from its explorers. But before Mars, the Moon was closer at hand to teach us how to live on a world beyond Earth. We can imagine the near future, a small cluster of habitats set up on the lunar surface, perhaps within the next decade or two. They might choose a site like the rim of Shackleton Crater at the Moon's south pole, where the sun's rays provide constant light and energy for solar panels, and where just nearby in permanently shadowed craters there lies ice, frozen water, delivered by comets over eons. That water can be extracted and split into oxygen to breathe and hydrogen for rocket fuel, or simply melted and purified for drinking and farming. A lunar base would start small, maybe a few connected modules delivered by robotic landers, inflated or assembled on site by astronauts or automated machines before a crew moves in. The first crew might number only 4 or 5 people, akin to an Antarctic winter over team, living in close quarters under experimental conditions. They would test all the systems needed to keep humans alive and productive off Earth long term. They'd refine techniques for using the Moon's materials to support themselves. For instance, crushing local rock, regolith, and melting or sintering it to form bricks, or extracting oxygen from the regolith, since lunar soil is rich in oxides, to add to their life support supply. Robots would likely assist them in building radiation shields, perhaps piling regolith over habitats, or filling bags or 3D printed blocks to stack into walls. Life in a lunar base would at once be novel and routine. The astronauts would wake in their habitat's small crew quarters, perhaps to the artificial tones of an alarm and the hum of ventilators. Through a small porthole or on an external camera feed, they might see the Earth eternally hanging on the horizon, shining blue and white. After breakfast, they don lightweight work suits for the comfortable pressurized environment of their base to do maintenance, checking the greenhouse plants grown under LED lights, or repairing a 3D printer that's churning out spare parts from lunar dust. Then, when it's time for an excursion outside, an EVA, extravehicular activity, on the Moon, they would suit up in their bulkier vacuum-rated suits, pre-breathe oxygen to avoid decompression sickness, and step through an airlock onto the Moon's surface. How different their routine would be from an Earth morning commute. Instead of getting in a car to drive on paved roads, they cycle an airlock, then perhaps climb into a small pressurized rover. With a colleague, they drive out across the powdery ground to a nearby crater where prospecting robots have indicated a high concentration of ice beneath the soil. They park and step outside, each footstep kicking up a little puff of dust in the 1/6 gravity. They drill into the soil, extracting a core sample to confirm the presence of ice. They deploy a device to heat and capture water vapor from the regolith, proving out the technology that one day could supply a full lunar settlement. As they work, they are conscious of being utterly dependent on their suits and each other. They speak occasionally over the radio, terse, calm communications about readings and safety checks, punctuated by long silences broken only by the sound of their breathing. Above them, the sun arcs low in the sky. Near the poles, it skims the horizon. And Earth, large and brilliant, slowly rotates, showing them first Africa, then Europe, then the glittering Pacific as time passes. At the end of their EVA, they gather the harvested water ice and geological samples, load them into the rover, and return to base. They enter the airlock, the dust of the Moon clinging to their boots. They've set up a sort of mud room, antechamber, where they use brushes and vacuums to try to remove as much dust as possible. Lunar dust is notoriously clingy and abrasive, smelling like spent gunpowder to those who've returned from EVAs. It can irritate lungs and eyes, so they take great care to keep it out of the habitat. Once unsuited, they clean the precious water they collected. Tonight, some of that very ice may be melted and sipped as a cool drink. a true taste of the moon, consisting of molecules that perhaps froze in shadow millions of years ago. In the evening, the crew might gather and recount the day's accomplishments. Perhaps they video chat with mission control or even with family on Earth, showing off a moon rock or simply letting the camera peek out a window at the surreal landscape beyond their habitat, a grey horizon under a starry sky with Earth hovering. After dinner, one of them might step outside alone for a moment, in a suit of course, just to stand in the pale lunar daylight and reflect. She looks at Earth and thinks of all the human beings down there, completely oblivious to the dusty plain she's standing on. She thinks of the explorers who came before, the Apollo crews who first walked here and looked up at Earth, just as she is doing now, decades later. The lunar windless silence and the eternal sky make it feel almost sacred, as if standing in a timeless cathedral of nature. This scenario is likely only a few years or a decade in our future. The plans are already on drawing boards. Rockets capable of delivering large payloads to the moon are being tested. The driving idea is to learn how to live off Earth on the moon, where help is relatively near if needed, and then use that knowledge to push on to Mars. Mars is a far bigger challenge. It is a world with air, though too thin to breathe, with weather, with seasons, and a day-night cycle, almost like Earth's. But it is incredibly far. A crew that goes to Mars will be separated from Earth by an unimaginable gulf. At closest approach, radio signals, our fastest means of communication, take about 4 minutes one way. At farthest, up to 24 minutes. Real-time conversation or emergency assistance will be impossible. The crew must be autonomous and resilient. The journey itself will test them with long exposure to microgravity and cosmic radiation. They will endure confinement, even more extreme than on the space station. Many months in a space perhaps the size of a large truck or two, shared with a handful of others, no escape possible. The psychological pressure will be immense. Yet, even with these challenges, the siren call of Mars is strong. Why? Perhaps because it is a world with tantalizing similarities to our own past. Mars shows evidence of once having had rivers, lakes, maybe even an ocean. It's a world where life might have arisen in ancient times. To set foot on Mars is to take our quest for exploration to a new planet entirely, to search for signs of past or present life, and to possibly lay the foundation for a future branch of human civilization beyond Earth. In the next couple of decades, with sustained effort and funding, we might see the first human mission to Mars launched. It will likely involve international and possibly commercial cooperation. A crew chosen from the best of many nations, riding in a spacecraft assembled and fueled perhaps in Earth orbit or lunar orbit, to reduce the mass that has to be launched from Earth all in one go. They will wave goodbye to Earth and then spend long months in deep space with only the faint glow of our planet and then the sun for comfort. When they finally approach Mars, how surreal it will be. From a reddish star in the sky, Mars will grow to a sphere beneath them, with ochre deserts and white polar caps coming into view. They will strap into a landing craft and descend through a sky alien but strangely familiar. There will be a thin whistle of atmospheric entry, unlike the silent vacuum descents to the moon. A parachute will likely deploy, buffeting them in the thin air, and retro rockets will fire to slow them in the final moments. The craft's legs or wheels will touch Martian ground amid billowing dust. When the hatch opens, a human will set foot on Mars for the first time. She will look up at a salmon-pink sky and perhaps see the sun looking smaller than it does from Earth. She might see one of Mars's small potato-shaped moons, Phobos, rising, just a quarter the apparent width of our moon. Beneath her boots, the soil has a rusty hue, laden with iron oxide. Those first footsteps, humanity's debut on a new planet, will electrify the world's imagination, much like the moon landing did, perhaps even more so after decades of build-up. Mars will immediately feel both more hospitable and more hostile than the moon. more hospitable, because there is a horizon at Earth-like distances, an atmosphere you could almost throw a paper plane, though it would fall quickly, and a gravity 38% of Earth's, enough that walking will feel somewhat normal, not the bouncing, slow-motion leaps of the moon, but more hostile, because that thin CO2 atmosphere offers no oxygen and only feeble protection from radiation. If the explorers crack their helmet seals here, they will suffocate in moments. And unlike on the moon, a quick return to Earth isn't possible. They are truly on their own. Over the next weeks and months, those Mars explorers would conduct a flurry of activity. They'd set up a base, likely using pre-delivered habitat modules that landed before their arrival. Perhaps they'll inflate a habitat or assemble one from components with the aid of robots. They'll establish life support, hooking up machines to generate oxygen from the Martian air. Some experimental devices to do this have already been tested by robotic rovers, setting up solar panels or a nuclear generator for power, and outfitting their new home with all the necessities for long-term living. They'll likely have a greenhouse unit to start growing hardy plants, both for food and to recycle CO2 into oxygen. Imagine the morale boost of seeing green leaves and tasting a fresh salad after months of space travel and rehydrated meals. Early on, they'll also focus on something critical: securing water. While an initial supply would come with them, long-term survival depends on using Martian resources. Mars has water ice underground and at its poles, and possibly briny water occasionally flowing near the surface. The crew might drive in a pressurized rover to a site identified from orbit as rich in ice, then drill or bulldoze to collect the ice or soil. They could haul it back to base and melt it, filtering out the fine dust. That water would then be fed into their life support system, providing drinking water, moisture for plants, and when split into hydrogen and oxygen, filling tanks of breathable air and maybe even topping off rocket fuel reserves. Each day on Mars, which lasts 24 hours 39 minutes, almost the same as Earth's, will settle into something like a routine, though every day brings new problems to solve and wonders to discover. The crew might spend the morning in their laboratory, analyzing soil samples under microscopes and chemical analyzers to search for organic molecules or signs of ancient microbes. In the afternoon, they might put on their suits and venture outside to deploy a network of sensors or excavate a trench in a dry lake bed, seeking evidence of long evaporated water. On a special day, they might drive many kilometers from base to visit a particularly intriguing site, say the delta of an ancient river, where the sediments might preserve the remains of Martian life, if it ever existed. They could park their rover and wander that landscape, much like geologists hiking in a remote desert on Earth, except each step is taken deliberately in a bulky suit, and every rock they examine is from a world that until recently was seen only through robotic eyes. Throughout their mission, Earth is in the sky of Mars, but it's just a bright star-like point. At night, if they pause and look up, and they will, inevitably, with a sense of poignancy, they will see Earth shining as the morning star or evening star on Mars's horizon. What thoughts will cross their minds? Likely longing, knowing that everyone they love is on that tiny dot, but also perspective, because from Mars, all humans are truly together on one little globe. Mars will test these explorers physically and psychologically. They'll face dust storms that can blow for weeks, dimming the sun and forcing them to ration power. They'll deal with equipment breaking far from any workshop. They will become adept at jury rigging and improvisation. They might discover disappointments, like finding that some expected resource isn't as rich or accessible as predicted. But they will also make incredible discoveries, perhaps finding new minerals or signs that Mars was habitable in the past. Maybe even clear evidence of fossilized microbes in a drilled rock sample. Such a discovery would be one of the greatest in scientific history. The first proof that life is not unique to Earth. As the months wind on, the crew will adapt. Mars will start to feel like home in some ways. They'll give names to local landmarks. They might develop little routines to keep sane. Perhaps a weekly movie night
where they gather in their habitat to watch a film stored on their computers, munching on treats from Earth and maybe some Martian-grown snacks. They'll celebrate each other's birthdays or a holiday, decorating their habitat with the limited materials on hand. One could imagine a Christmas on Mars, with a tiny tree-like plant from the greenhouse adorned with makeshift ornaments, and the rover's headlights serving as festive lights. Communication with Earth, though delayed, will be a lifeline. They will send and receive video messages. A sonorous "Hello from Mars" might arrive on Earth, and 15 minutes later, the crew's families and millions of strangers will see their red-suited figures waving amid an orange-red landscape. In turn, news and encouragement flow back. But with time, the Martian explorers will form their own tight-knit society, small as it is. They'll have inside jokes about the quirks of living on Mars, moments of friction and reconciliation, shared triumphs that only they fully understand. They might start to feel, in a way, Martian, connected to this rusty world as their second home. After perhaps a year or more on Mars, if it's a round-trip mission, they'll prepare to come back. They'll pack their samples, kilograms of Mars rocks, and maybe, just maybe, a carefully sealed container holding evidence of life. They'll tidy up the base and perhaps leave certain equipment behind for the next crew or for a future permanent outpost. They'll board their ascent vehicle and blast off to rendezvous with the craft that will carry them home. It will be a bittersweet departure. Relief at the thought of Earth's blue skies and oceans awaiting them, but sadness to leave the place they explored and made their own. As one of them radios, "Mars base has cleared the surface." There might be a lump in her throat. In a short time, Mars shrinks beneath them. The base they built becomes an indistinguishable speck in a vast reddish expanse. They are astronauts in space again, leaving one world, bound for another. The trip home will seem to drag in ways the frenetic outward journey did not. Mars recedes to a red dot. Earth slowly grows to a pale blue dot, then a crescent, then the full globe. They will have plenty of time to reflect on what they've done. Perhaps they'll write hundreds of pages in journals or spend hours staring out a window at the stars, contemplating the strange duality that now defines them. They left Earth as their entire world, and now have left another world to return to their first. They carry experiences no one else on Earth has had. When at last they plunge through Earth's atmosphere and the parachutes deliver them to an ocean or desert landing site, they will step out like aliens. Gravity suddenly 3 times what they've felt for over a year will press on them. Earth's air will burst with rich smells and humidity that feels thick to breathe. The familiar blue sky might even overwhelm their senses after so long, under a dusty pink Martian sky or the black of space. They will be celebrated worldwide. Parades, interviews, accolades, these await them. But inside, they will know that the journey is only truly meaningful if it is followed by others. They will likely say, "We were just the first wave. Others will do even greater things." They might already be planning a return or encouraging the establishment of a permanent base with a larger population. Mars will by then have gone from a twinkling idea in the sky to a real place in the human realm of experience, with known valleys, plains, dangers, and wonders. Humanity's first forays beyond Earth, from orbital flights to footsteps on the Moon, to long stays in space and expeditions to Mars, have been not just feats of engineering and bravery, but deeply emotional and philosophical undertakings. Each step has forced us to confront what it means to leave the cradle, to find ourselves in environments utterly indifferent to our survival, and yet to carve out a place for ourselves there. We have learned that we can adapt our technology and even our bodies through rigorous exercise, and eventually perhaps through medicine, to places beyond Earth. We have also learned that exploring space changes how we see ourselves. The astronauts invariably return with a greater appreciation for Earth and a keen sense of the unity of humanity. As humans push on to set up a foothold on the Moon and eventually a settlement on Mars, the logistical and emotional burdens will be immense.
The crew of a Mars mission, for example, must endure isolation akin to that of a ship at sea in uncharted waters, knowing that real-time help is out of reach. They must be psychologically strong, with a sense of purpose and the ability to cope with long periods of confinement and monotony, punctuated by moments of high stress and awe. On Earth, we will have to support them as a whole planet, with attention, goodwill, and an understanding of the risks they undertake. Once we have people living on the Moon and Mars, even in small numbers, humanity will have truly become a multi-world species. This will bring challenges that aren't just technical, they are cultural and ethical. We will have to decide how to govern these new communities, how to share the benefits, how to avoid conflict over off-world resources, and how to include all of humanity in this expansion, not just a privileged few. In parallel to sending humans outward, we have also sent our mechanical envoys to pave the way and to reach places human bodies cannot, at least yet. While astronauts took tentative steps beyond Earth, our robotic probes leapt across the solar system and beyond, extending our reach to every planet and many moons. In some sense, these robots have been the vanguard of our species, precursors mapping the terrain for eventual human footsteps, and explorers in their own right, accomplishing journeys we ourselves might not undertake for generations, if ever. Consider the voyage of our farthest scouts. In the late 20th century, we launched a pair of automated spacecraft on a grand tour of the outer solar system. These twin probes visited giant Jupiter with its swirling storms and volcanic moon, sailed past ringed Saturn, and even continued on to distant Uranus and Neptune, sending back the first close-up images of those remote worlds. They revealed things that humans might not see with their own eyes for centuries. Geysers erupting on Neptune's moon Triton, or the intricate structure of Saturn's rings. After completing their planetary missions, these probes continued on, coasting at tens of thousands of miles per hour. Decades later, they left the heliosphere, the bubble of space dominated by the sun's wind, and entered true interstellar space. They are now truly star-bound, though it will be tens of thousands of years before they approach another star. Each carries a golden plaque or record with messages from Earth, a snapshot of our world in case some distant future intelligence finds them. These silent travelers, powered by the slow decay of plutonium and carrying our greetings, are like bottles cast into a cosmic sea. Elsewhere, we have sent orbiters and rovers to our planetary neighbors. Mars, especially, has become almost a second home for our robots. We have more or less continuously had robotic presence on Mars since the late 1990s. They have orbited, mapping the entire planet in detail. They have landed, scratched the soil, sniffed the air, and rumbled across plains and crater floors. One hardy rover that landed in the early 2000s was expected to last 90 days. Instead, it kept going for about 15 years. It trekked for miles across Mars, from one crater to another, photographing its tracks in the dust, climbing hills and descending into valleys, until a massive dust storm finally covered its solar panels, and it fell silent. When its mission ended, people on Earth felt a surprising pang of sorrow. We had come to anthropomorphize this machine, to see it as an extension of ourselves on Mars. Indeed, when it stopped communicating, one engineer poetically summarized its last message as, "My battery is low and it's getting dark," a poignant humanizing of the final telemetry. Millions around the world reacted as if a beloved pet or colleague had been lost. Why? Because that rover and its twin on the opposite side of Mars and its successors represented us. Its eyes were our eyes. Its discoveries, our discoveries. Through it, we vicariously roamed another world for the first time. We've done the same with the Moon and other bodies. Long before people returned to the Moon, robots scouted it. They circled the Moon, mapping every crater and mountain, landed to test the terrain, and even brought back samples with automated return rockets.
We've landed probes on Venus, briefly surviving the hellish heat to send back a single photo of a barren, slabby landscape under a leaden sky. And on Titan, Saturn's largest moon, parachuting through its orange haze to land on pebbles by the edge of what seemed to be a methane lake. We've sent spacecraft to comet nuclei, even landing on a speeding comet to directly taste its surface materials, and to asteroids, where they touched down and grabbed bits of rock to return to Earth. We've built giant telescopes that float in orbit, above the blur of our atmosphere, to peer into the depths of the universe. One orbiting observatory opened our eyes to the beauty of stellar nurseries, vast pillars of gas and dust where new stars are born, and to the reality that even apparently empty patches of sky are filled with countless distant galaxies. Another newer space telescope, parked 1 million miles from Earth, has looked even further back in time, capturing the faint glow of the first galaxies that formed mere hundreds of millions of years after the universe's beginning. It's also studying planets around other stars, detecting the fingerprints of water and other gases in their atmospheres, giving us the first tantalizing characterizations of worlds light years away. These machines, marvelous as they are fundamentally our proxies. They have no consciousness. The wonder of the discoveries is felt here by us when the data and images come home. We sometimes give them names and personalities in our narratives. We speak of Voyager sailing the cosmic ocean, or the rover taking a selfie on Mars, or a telescope seeing the birth of galaxies. This is more than just convenient shorthand. It reflects that we have invested these creations with a piece of human spirit. They extend our senses and reach, allowing us to be virtual eyewitnesses across the solar system and beyond. They also, in many cases, prepared the way for human explorers. Robotic orbiters around Mars identified safe landing sites and located resources like water ice, directly helping planners of future crewed missions. A rover on Mars recently tested converting carbon dioxide from the atmosphere into oxygen, demonstrating technology that human settlers might rely on one day. Our mechs have been pathfinders, surveyors, and sometimes guinea pigs, showing us where we might go and what to expect. In some places, they are likely to be the only explorers for a very long time, perhaps centuries or more. Jupiter's radiation belts, for instance, are so intense that no human could survive there without extraordinary shielding, but our probes have dived in and orbited Jupiter, braving that environment to photograph its swirling clouds and probe its gravity. The surface of Venus is so hot, enough to melt lead, that no human could survive there even in a suit, but landers sent in the 1970s lasted a few minutes to an hour, giving us our only direct view of that furnace-like world. The prospects of humans wading through the hydrocarbon lakes of Titan or floating in the clouds of Uranus are distant at best, yet our robotic emissaries have sampled those environments for us. In this way, our robots expand the human presence intellectually, if not bodily. When a small drone helicopter buzzes in the thin air of Mars, as one is doing now, carried by a rover, we celebrate it almost as if one of our own had grown wings. When a probe on the far edge of the solar system turned its camera back and captured a tiny dot that was Earth, a pale blue dot against the vastness of space, it was actually an extension of human eyes that took that picture, by instructions of a human mind, to give us a perspective we ourselves couldn't yet physically achieve. The philosophical nature of sending machines instead of ourselves is rich. On the one hand, practical necessity. It's far cheaper and safer to send a robot into harm's way. There's no risk of tragedy or loss of life if it fails. On the other hand, by doing so much robotically, are we removing the human experience from exploration? Is a discovery as profound if no person is standing there to feel the crunch of alien soil under their boots, to directly hear the whisper of an alien wind, or rather, to see the movement of dust, since no human ear could hear the tenuous Martian breeze through a helmet? Some argue that a human geologist on Mars could do in a week what it takes a rover months to achieve, with deeper insight and creative intuition. Others respond that without the rovers,
we wouldn't know where best to send that human geologist in the first place. And that for many places like the outer planets, robots are the only explorers we will have for generations. There is also a sense that these robots are the pioneers for humans not yet born. The first people to walk on Mars will likely do so in places already made familiar by rovers. They may plant their boot next to a rover's wheel track, effectively hand off the torch of exploration from robot to human at last. And those distant space telescopes finding potentially habitable planets around other stars. They are scouting, perhaps, for the far future when our descendants might build starships to go see those worlds up close. Through our probes and telescopes, we have learned so much that the Sun is but one average star among billions in our galaxy, that every star in the night sky likely has its own family of planets, that organic molecules, the building blocks of life, form readily in space and rain down on other worlds via comets and meteorites. We've watched stars explode in supernovae and detected black holes merging. We've mapped the cosmic microwave background radiation, the leftover glow from the Big Bang, and even discovered evidence of mysterious phenomena like dark matter and dark energy that shape the cosmos. None of these breakthroughs involved a person leaving Earth orbit. All were done with the extension of human curiosity through instruments and machines. In this way, robotic exploration is not second-class or ancillary. It is a primary mode of exploration that complements human voyages. Each drives the other. The more our robots discover, the more we want to go ourselves. The more we yearn to go, the more we build better robots to lay the groundwork until we can. Consider the emotions stirred by a lonely rover singing happy birthday to itself on Mars, or by the final signal of a spacecraft as it bravely plunges into the clouds of Saturn at mission's end. We can't help but empathize, because those machines are out there doing something fundamentally human. They are exploring the unknown. When a space telescope captures the light of galaxies billions of years old, we feel that wonder, because it speaks to a human desire to know our origins. The telescope has no eyes that appreciate the majesty of a galaxy. We do. The rover has no nose to smell the Martian air or feel the texture of dust, but through its chemical sensors and cameras, we almost feel as though we do. In sending machines in our stead to far-off places, we've multiplied our presence 1,000-fold. At this very moment, there are machines wandering Mars, orbiters around the Moon, spacecraft cruising the asteroid belt, a probe awake in the Saturn system long after Cassini, and messenger devices sailing out beyond Pluto, all far beyond the reach of any human traveler. We have become a multi-present species through our robotic avatars. It's an incredible achievement and a testament to human ingenuity. And crucially, it's not separate from human exploration. It's an integral part of it. The Apollo astronauts carried a primitive rover to the Moon to extend their range. The Mars astronauts will use advanced rovers to scout ahead and carry heavy tools. The first interstellar mission from Earth might well be a fleet of tiny sail chips, not people, but those chips will carry our senses and perhaps even our recorded voices and names to the stars. So, while humans and robots sometimes are portrayed as in competition for exploration priorities, should we send astronauts or probes? In reality, they are partners. The probes often go first, like the scouts of an advancing army. And even where humans cannot go, they go on our behalf and return the gift of knowledge. As we look to the near future, this partnership will continue. We plan to send new robotic landers to the Moon to prospect for resources, even as astronauts train to go there. We design more sophisticated Mars rovers to gather samples and leave them ready for a future return mission, bridging the gap until humans can retrieve them. We even discuss semi-autonomous habitats that might be sent to Mars and built by robots ahead of a human crew's arrival, so that when people step off the rocket, there is a functioning base waiting for them. Hand in hand, humanity, in person, and humanity by proxy, via robots, are venturing outward. One day, perhaps, on a moon of Jupiter, or the surface of a distant dwarf planet, a human explorer will pick up a long-dormant robot that arrived decades prior, dust it off, and marvel at its antiquated electronics, a historical artifact of the first wave of exploration. It will be akin to early settlers finding a faded map left by pioneers. Our robotic explorers, then, are part of our cultural heritage already. Names like the first orbiting telescopes or deep space probes have entered language akin to explorers' ships, names of old. And just as the voyages of those ships changed the map of the world, the journeys of our probes have changed the map of our solar system from a set of blurry dots to real places with terrain and weather and history. They've also prepared us psychologically for living in space. Through the pictures and data they returned, they made places like the Moon, Mars, and even moons of Jupiter familiar in the public mind. When we imagine living on Mars, we populate our imagination with real panoramas taken by rovers. Pink skies, reddish rocks, a distant view of Mount Sharp as seen by a rover's camera. Mars is no longer just an unknown orb. It has landscapes we've seen up close, and that makes the idea of going there more concrete and compelling. The robotic chapter of space exploration, remarkable on its own, thus seamlessly blends into the human chapter that follows. And as it does, we must recognize that exploring is not just about the physical act of going somewhere. It is about broadening human experience and knowledge. The robots have broadened our experience vicariously in magnificent ways. They've allowed all of humanity, not just a select few astronauts, to share in the exploration. Not everyone can go to Titan or Pluto. In fact, no one can right now. But through our probes, effectively everyone did, watching through their electronic eyes. In that sense, robotic exploration is profoundly democratic. A little girl in an inland village who watches images from Mars come in is an explorer as much as the rover drivers at NASA, sharing in the discovery and wonder. Space exploration, done with humans or robots, is ultimately for everyone on Earth. Now, after decades of robotic reconnaissance and tentative human steps, we stand on the verge of a new epoch. We are preparing not just to visit, but to inhabit other worlds. The Moon will likely host a continuously occupied station within our lifetime. If that succeeds, Mars may not be far behind in the decades to follow. We will then have to confront the reality that our species is spreading beyond its birthplace. This is a momentous development, one as profound as when life first crawled out of the oceans onto land. As we extend our presence into space, we carry more than just machinery and fuel with us. We carry our humanity, our cultures, our laws, our stories, and our moral values. Becoming a spacefaring species will test and transform these aspects of ourselves in profound ways. It forces us to ask, how will we govern ourselves beyond Earth? How will we preserve our cultural identity and also create new ones in alien environments? How will we ensure that expanding into the cosmos is done ethically and for the benefit of all, not just a few? From a legal standpoint, humanity has already begun grappling with these questions. Decades ago, in an era of intense geopolitical rivalry, nations came together to lay down some fundamental principles for space. Through international agreements forged in the late 1960s, they declared that outer space, including the Moon and other celestial bodies, shall be the province of all humankind. Space was not to be carved up like old colonial territories. No country can claim sovereignty over the Moon or Mars, plant a flag and say, "This is mine." The use of space is to be carried out for peaceful purposes and for the benefit of all peoples. These principles, born at a time when astronauts carried national flags on their arms, were a remarkable commitment to unity and restraint. As we move from brief forays to possible settlement, these principles will be tested. What happens when there is a permanent settlement on Mars? Will it be under Earth jurisdiction? If so, whose? Or will Mars eventually govern itself? If private companies mine asteroids for valuable metals or extract water from the Moon to sell as rocket propellant, how do we regulate that to prevent conflict and ensure fairness? Already, new policies are being discussed and tentative laws passed allowing companies to own the materials they mine in space, even as space remains not owned by any nation. We are, in effect, extending concepts of property and commerce beyond Earth, but carefully within the framework that space is a global commons. It's crucial that we do so in a way that avoids a Wild West grab or confrontation over resources. There is plenty in space for all, if managed sensibly. The resources of one small asteroid could be worth trillions of dollars. But human history teaches that perceived scarcity or lack of regulation can lead to competition and conflict. So, part of becoming spacefaring is developing new laws and norms, perhaps new treaties, to handle things like mining rights, environmental protection off-world, and the rights and responsibilities of space settlers. Culturally, venturing into space has already begun to unite us in unexpected ways. When astronauts from multiple countries live together on an orbital research station, they share meals and music and stories, and they find common ground in the sheer uniqueness of their situation. In orbit, an American and a Russian realize they depend on each other absolutely. Whatever political tensions exist on Earth fade in relevance compared to the need to cooperate to maintain life support or conduct a joint spacewalk. This model of international partnership, supported by ground teams across numerous countries, has largely been a success story. It hints that as we go further, to the Moon, to Mars, cooperation might be the key to success. Already the plans for a lunar gateway station and base involve many nations and even private companies working together. The first person to step on Mars might plant not only their nation's flag, but also perhaps raise a flag that represents all of Earth, symbolizing that we made it there as a world, not just as one country. Identity will inevitably evolve in space. The first people born off Earth will mark a new branch of the human story. Imagine a child born in a small lunar settlement. She grows up seeing Earth in the sky, knowing that's where her parents came from, yet her own memories are all of the Moon's domes and tunnels, the low gravity in which she can leap 6 times higher than on Earth, the lack of open-air parks and oceans. Maybe she has a little patch of plants in a greenhouse to play in. Will she think of herself as Earthling or something new, a Lunarian, perhaps? The likely answer is both, but over generations, new identities will form. Maybe distinct dialects or languages will develop in isolated space communities. Certainly distinct customs and folklore will. Even on the International Space Station, crews develop traditions. They all sign a wall panel before departing. They play practical jokes on each other when someone is about to leave, like hiding a rubber snake in their cabin as a gag. They share an international meal, where everyone brings out food from their culture to share. One can imagine lunar base crews creating their own rituals. Perhaps every Earthrise they pause work to collectively watch it and reflect, or they devise new sports adapted to lunar gravity. Culture is adaptive. It will flourish in new environments, blending old Earth traditions with creative new practices suitable for life on the Moon or Mars. Memory plays an interesting role here. Those living off Earth will strive to remember where they came from, to not lose the connection to Earth's history, and to avoid repeating old mistakes in their new world. The colonists of a Mars settlement might bring with them a digital library encompassing all of Earth literature and history. It would be wise to do so. In their colony's school, children might learn about Socrates and Shakespeare and Sun Tzu and the Holocaust and the Renaissance and everything that shaped human civilization, because they need that context even as they start writing Martian history. We don't want off-world settlements to culturally drift into ignorance or myth about Earth. Maintaining that shared memory will help keep humanity one people even as we spread out. And the reverse is true too. Earth will remember those explorers. The first steps on the Moon have never been forgotten. The words spoken that day are in every history book. The first footprints on Mars, the first baby born off Earth. These will likewise become part of the human saga, events commemorated for centuries to come if we endure. It's incumbent on those of us on Earth to support and remember the voyagers, to treat them not as exiles or mercenaries, but as heroes and pilgrims carrying our collective hopes. Ethically, space expansion brings new questions. One profound issue is planetary protection, the moral responsibility to avoid harming life that may exist elsewhere. If we find even simple microbes on Mars, what then? Do we halt human expansion to avoid contaminating or competing with Martian life? Some argue that Mars should be left entirely to any native life it harbors, effectively off limits to settlement, except perhaps in regions conclusively proven sterile. Others propose a compromise. Human exploration should go ahead, but under strict protocols to minimize contamination, and certain parks or preserves should be set aside where Martian life, if present, is left untouched and studied in situ. This is not unlike conservation debates on Earth, except here we are, the invasive species entering someone else's habitat, even if that someone is a microbe. It feels strange to worry about protecting hypothetical bacteria, but it speaks to a broader principle. As we become able to affect multiple worlds, we carry with us a responsibility to be good stewards, not reckless despoilers. There's also the question of our environmental impact beyond Earth in a broader sense. On Earth, we've awakened to our effects on ecosystems and climate. As we expand into space, we ought to apply those lessons early. For instance, space debris in Earth orbit, discarded rockets, defunct satellites, has already become a hazard. We will need rules to keep Earth orbit usable. Plans for space junk removal missions are underway. On the Moon or Mars, we should avoid unnecessary pollution or landscape damage. It might sound trivial. After all, there are no ecosystems there. But preserving scientific value is important. Future generations might treasure untouched lunar landscapes in their natural state, the way we value national parks. If early industry on the Moon ran amok and blasted entire regions indiscriminately, we might regret it when we realize those crater walls held geologic records or aesthetic grandeur that we care about. Essentially, extending our environmental ethics to other celestial bodies, even if they are barren, reflects a respect for worlds as natural archives of cosmic history and potential homes for future life. Another ethical dimension: how we treat each other as we spread out. Space settlements will likely start under some Earth authority, but as they grow, issues of rights and governance will come up. We need to ensure that people living off-world have a say in their fate and are not exploited. It is conceivable that early settlers might be employees of a company or members of a government expedition with a chain of command to follow. But over time, as they become true residents, they will want self-determination. Imagine by 2100, if there's a Mars town of 1,000 people who consider Mars their home. Would they be content to be governed by remote officials in Washington or Beijing or elsewhere on Earth? History says probably not. They might insist on forming their own governing council, eventually a government. Earth governments will have to choose whether to treat off-world colonies as just extensions of their territory, like colonial outposts, or as new societies that deserve autonomy. The ideals we hold, freedom, democracy, human rights, will need vigorous affirmation in these new environments, lest power dynamics twist them. For instance, could a private company essentially enforce a corporate dictatorship in a space mining colony? That might sound dystopian, but it's not inconceivable if laws lag behind reality. We'll need clear agreements that, for example, basic rights travel with humans beyond Earth, that a worker on the Moon has no fewer rights than one on Earth. We also have to grapple with cultural inclusion. For space to truly be for all humanity, eventually people of all backgrounds should have the opportunity to be part of it. Initially, astronauts and even space tourists come predominantly from wealthier, technologically advanced societies. But just as exploration of Earth went from the monopoly of a few empires to a globe-spanning endeavor involving many peoples, so should space. Already, we see this democratization. Astronauts now hail from a wide array of countries. Private companies seek to drop launch costs dramatically, potentially opening access to space to many more groups, including universities, smaller nations, even individuals. If the cost to reach orbit drops enough, we could see a boom akin to how air travel became common. Perhaps later in this century, leaving Earth's atmosphere might be routine for many, not just a select few. If a Mars settlement arises, we might hope it includes people from every continent so that it truly represents Earth's diversity, living proof of the "for all mankind" credo. Culturally, think of the arts. Space already has inspired so much art. Paintings of galaxies, science fiction stories, music, from Holst's The Planets to David Bowie's Space Oddity. Once people live in space, they will create art in space. There might be zero-G sculpture or moondust pottery or Martian landscape photography that rivals Ansel Adams' works of Earth's national parks. New myths and stories will develop. Children on Mars might have local folktales about the sand spirits of dust devils or the adventure of the first explorers. Our culture will expand, enriched by these new narratives and creations from beyond Earth.
Our religions will also extend into space. Already, astronauts have found ways to observe religious practices in orbit. One Apollo astronaut famously read from Genesis while orbiting the moon. Muslim astronauts in orbit figure out how to face Mecca when the Earth is constantly moving below them. An Israeli astronaut once orbited and attempted to keep track of the Sabbath according to the last sunset he saw. We'll have to consider Sabbath on Mars. A Mars day is slightly longer. How to adjust ritual times. And where is east for prayer on the moon, perhaps just toward Earth? These might seem like trivial technicalities, but they show a deeper point. We will adapt our deepest traditions to new worlds, and those traditions will also evolve in the process. Philosophically, leaving Earth tends to heighten a sense of unity and also existential reflection. When humans are living on two planets, the notion of Earthlings as a single group becomes practical. In dealings between Earth and Mars, all people of Earth might naturally be on the same side. Perhaps petty distinctions of nationality will soften when viewed from an outsider's perspective. Conversely, we might have to manage a possible us versus them mentality between planets. Science fiction often explores tensions between Earth governments and Mars colonists. But if we lay the groundwork with values of unity and shared heritage, and communications remain robust, so Mars colonists still feel culturally connected to Earth, we can hope to avoid unnecessary estrangement. Memory on multi-generational timescales is crucial too. If, over centuries, Mars or other colonies become self-sustaining and Earth's influence wanes, will they remember they came from Earth? It would be important to keep that history alive to avoid misconceptions or destructive myths. Perhaps they'll commemorate Earth Origin Day, or maintain archives of Earth literature, like we said. On Earth, will people remember or care about a distant Mars colony? Perhaps news from Mars becomes as routine as international news. Ideally, yes, a sense of kinship maintained across space. But complacency or conflict could sever ties. It will take conscious effort and goodwill to ensure that our expansion doesn't lead to division in the human family. Ultimately, becoming a spacefaring civilization is not just a technological evolution, but a moral and cultural one. It challenges us to enlarge our definitions of community and home. Home will no longer mean only the Earth. For some, home will be a tin can hurtling to Jupiter, or a dusty habitat on Mars, or a spinning asteroid colony with artificial gravity. We will have to decide what core values travel with us. Do we carry the seeds of war and prejudice outwards, or do we use the fresh start of new worlds to build more equitable societies? There is an opportunity in frontier environments to do things differently, the way new nations sometimes designed more progressive constitutions than the old ones they left. Perhaps a Mars settlement will decide to eliminate certain social ills by design. Maybe they'll establish from day one complete gender equality, or ban certain weapons, or institute communal ownership of critical resources like air and water to prevent inequalities.
they might be small enough to reach consensus in ways complex Earth societies struggle to. Of course, they could also make mistakes or new inequalities could arise. Imagine tensions between those who pilot spacecraft and those who do the hard labor of habitat construction, for instance. Human nature will play out on these new stages, for better or worse. One delightful certainty is that we will carry our sense of wonder and curiosity wherever we go. Martians, as future people may call themselves, will look up at their night sky and still be captivated by the stars and by Earth shining among them. Lunarians will stand at the rim of a lunar crater and still feel the sublime awe of the cosmos above. We sometimes fear that venturing out might make us lose our appreciation for Earth's beauty or the cosmos's grandeur, but evidence suggests the opposite. Every astronaut comes back an environmentalist, more in love with Earth than ever and deeply moved by the wider universe. Similarly, those who settle beyond Earth will likely hold a special reverence for Earth as the birthplace of humanity, a kind of ancestral holy ground. They might also treat the universe itself with a kind of spiritual respect, having seen more of it up close. In the end, all these cultural, ethical, and philosophical considerations underscore a powerful truth. As we explore space, we are really exploring ourselves. We are testing our values, our social systems, our creativity, and the resilience of our spirit. Space will not solve our problems or change human nature by itself, but it will give us new perspectives and contexts in which to confront those problems and grow. Perhaps the most profound cultural impact of becoming spacefarers is this perspective shift. We've mentioned the overview effect, the change in worldview astronauts report when seeing Earth as a fragile disk in space. Imagine when not just a handful, but generations of people have that experience, either directly or ingrained in their community's heritage. It could create, over time, a more mature global consciousness. The narrative may shift from, "I am from this nation," to "I am human. I come from Earth. We all do." That doesn't erase local cultures, we wouldn't want it to, but adds an overarching identity that may help us cooperate on global issues like climate change or peace. Furthermore, space exploration puts into perspective the commonality of all life on Earth. When searching for life on Mars, or hearing about potentially habitable planets around other stars, we become more aware of the rarity and preciousness of life. It can inspire a planetary stewardship ethic. Knowing how special Earth is may galvanize efforts to protect its biosphere. So, as we conclude this journey through imagination and reality, from the silent vacuum of space to footprints on alien soil to dreams of distant stars, we see that space exploration is far more than the sum of its technological parts. It is a human story, one continuous with our long history of exploration and migration, but entering a new chapter that challenges us to evolve in mind and spirit. Space exploration is not simply the future. It is the present. Even now, astronauts circle Earth, machines rove Mars, and engineers build rockets to return humans to the moon and beyond. It is happening in laboratories, launch pads, and classrooms today. Its benefits and perspectives are shaping our world already, from satellites that connect and inform us, to the philosophical insights ordinary people gain seeing Earth from space, through astronauts' eyes, or even through virtual reality. The journey outward influences how we live on Earth now. And it's not really about rockets or spacecraft or any hardware. Those are just tools. Ultimately, it's about perspective. It's about expanding what we consider our world, from a single planet to an entire solar system, and one day, perhaps to a galaxy of stars. It's about seeing ourselves from a higher vantage, realizing the unity of our little globe and the universality of our aspirations. The rockets, the suits, the rovers, they are the means. The end is knowledge, vision, and perhaps wisdom. Finally, space exploration is not an endeavor reserved for a few astronauts, scientists, or billionaires. It is, or should be, for everyone. Its fruits enrich all humanity. The communication satellites that enable a call across continents, the new materials and medical techniques developed through space research, the inspiration that fuels young students to study science or engineering or art and literature with a cosmic theme. When a human walks on Mars, all of us will walk there in our hearts. When our robot finds evidence of life beyond Earth, it will be a discovery that belongs to every person under the stars. In this sense, the voyage into space is a collective journey. Just as our ancestors spread to every continent together over millennia, we as a species are now taking the first steps beyond the shore of our cosmic ocean. Each step is taken by individuals, a man in a suit, a woman at a console, but behind them are thousands supporting, and behind those thousands are millions cheering and billions more standing to benefit from the results. We go to space as the human race. What lies ahead will surely surprise and challenge us. There will be setbacks, dramatic failures, maybe tragedies, and grand triumphs that lift hearts around the world. There will be moments of solitude in a capsule far from home, and moments of camaraderie when an international crew shares a meal while orbiting the moon. There will be ethical dilemmas and ingenious solutions. There will be times when we question why we spend resources up there, and times when something from space saves countless lives or opens new wealth down here. Through it all, if we remain true to the best of our nature, our curiosity, courage, and compassion, the expansion into space can unify and uplift us. Looking up at the night sky, we have always felt a mix of longing and belonging. Now we know we belong in that sky too. We carry bits of stardust in our bodies. We emerged from the universe and developed eyes to behold it. Our exploration of space is really the universe coming to know itself through us. Each footprint on the moon, each image from a distant probe, is the cosmos waking up a little more. Someday, school children may live on moons of Jupiter or in a settlement orbiting an exoplanet around another star. They will learn of these early years of the space age, when a single planet's inhabitants took their first halting steps beyond their cradle. They may see it much as we see the age of exploration or the first voyages of seafaring peoples, an epoch of daring, folly, brilliance, and change. But perhaps, if we succeed, they will also see it as the time when humanity truly came together, realizing that we all share the same tiny home and the same vast aspirations. In the continuous fall of orbit and the open sea of space, we are discovering not only new worlds, but a new understanding of our own world and ourselves. The journey is just beginning, a dream that carries us through imagination, science, and time. And as we take these steps, tiny or giant, we carry everyone along, because this endeavor belongs to all of us. Space exploration is the present unfolding into the future. It is perspective shifting and profound. It is, ultimately, a human journey for everyone, by everyone, elevating everyone. All we need to do is continue the voyage, together, beyond the sky, into the endless night sprinkled with stars, and make it our own.